So we should have a chat. Yeah, actually. Yeah. So we have a chat function, guys. So I guess only me and Yorgos can talk for today. Sorry for that, but you can complain in the chat. And we're gonna start maybe in a few minutes. And the chat will also be used for Q&A. I'm gonna repeat it later when there will be more people, but okay. So please let us know if there's an issue with the audio, of course, as always. And if everything in the chat works, if you see, nice. Other things that I can say in the meanwhile is that, of course, the session will be recorded, and then all these recordings will pop up on YouTube at some point. We will let you know when and how. And yeah, if you have also other tips for us on how you want to see this through, like any preference on which tool we're using or like how to structure the session, that's also always very welcome. And yeah, the session will take approximately 1 hour. There is, as I said, a Q&A for chat, chat for Q&A. And but so you can ask questions or like throughout the whole sessions. Maybe we take them through the session. Maybe we take them at the end. No promises there. If they're long and the discussion goes through, there actually is a Discord server where we can keep the discussion going afterwards. And of course, you can reach out to all of us in other ways, but I think it's good if we use a Discord that has been set up. Okay. All right. I guess we can start. Let's see. Gonna do this. Okay. All right. So I'm gonna start. Hello, everyone. So welcome to this third session of the AMD Research Club and AI Research Club. And today we're going to talk about hidden shortcuts and hidden traces that our models can actually pick up during training, and we are not even aware of that. And then what are the implications of this? So we're going to talk about the implication in the performance of our models. If this is something positive, it's negative, it can be both of the two things at the same time, and how to mitigate it and what it means to mitigate it. If we want to mitigate it, first of all, and then can we do it or should we do it during the training? Should we do it afterwards? And this in general, I think it's a super interesting topic because it touches so many other things. It's such a fundamental piece of deep learning. It has always been like that. It's not like it's interesting because it like this topic keeps coming up to me, but then of course it's something that is always there, and every time it comes up with different implications and consequences, and so it's kind of one of those topics that never gets old, in my opinion. And as I said, it's kind of entangled to so many things because it entangled to domain adaptation and domain shifts, and it could be on many other implications that we have when we deploy models in the real world, including privacy and fairness. So for today, our speaker is going to be Yorgos Tolias from CTO in Prague. So Yorgos, I let you now. I'll give you the stage if you want to like introduce yourself, your group, and of course what you're gonna tell us today.
Okay, hi Pierre again. Thank you for inviting you and the fellows at AMD that are organizing that. Hi to everyone that is joining. Okay, so let me see. I try to familiarize myself a bit with this Miro tool that you suggested. I got scared at the beginning, but I start to like it. Okay, even though apparently I'm not so
Yes.
proficient. Okay, so a few things about myself. Yeah, so if I got this part, so I'm an associate professor at CTU in Prague. Yeah, I did my PhD. I started, everything started for me back in Athens, in Greece, born, raised there. Did my PhD there, then spent some time in France, at INRIA, for a postdoc. And afterwards, actually, I've been here, like in Prague, the last 10 years. Like starting as a postdoc, uh, and struggling and suffering to change my status every few years. Okay, actually, Prague has been very, nice to me. So I'm also a researcher at the Visual Recognition Group. Yeah, here is a screenshot of the members. It's quite a large group. See, like several faculty members, senior researchers, postdocs, PhD students, and we have also some very regular, let's say, undergraduate students. Nevertheless, within the group, I lead a small team. You can see here, these are the people that I have fun with, in daily basis. Yeah, we have our own playground within VRG, and we focus on computer vision tasks, same as the whole visual recognition group. But nevertheless, we have maybe our own topics that we're mostly interested in. Like so some of those are representation learning, a lot of image retrieval, recognition at a very fine grain level, like particular object recognition and understanding. Nevertheless, today's topic is none of our standard topics. Yeah? It's a topic I picked that one. It's I really like. Nevertheless, we started to work on it a bit coincidentally, which I may talk about. Yeah, how it all started. So, okay. So Pierre, yeah, we go ahead and we start talking about the work and the paper.
Yeah, of course. So today we have two papers, right? One is a ICCB highlight 2025, and then the other one is still a kind of a bit of a it's still under review. So cannot say which conference, but you guys can imagine.
Let's say going work, it's not public yet, but today I will show parts of it, like so the paper is loaded here on this platform. Okay. Yeah, so it's like a series of two papers from now on. So somehow we can say that, okay, somehow coincidentally, I will talk about it while working on a very different task. No,
Mhm.
we observed that something is happening. And then the first paper was more about, what is happening there, yeah? And what are implications of
Okay.
it. And then the following work is about, why is this happening? What can we do about it? And again, what are the implications? So how it all started, okay? So let me describe the
Mm-hmm.
context. We were working on something very different. We're creating a new data set for retrieval, okay?
Okay.
For particular object retrieval, and we had a team that was collecting the images actually, and we had a query like this. Maybe I will zoom in more of this object, and positive images. The ones here with a green border, so they're showing the same particular object in different conditions. Okay? And we had lots of different objects like that, queries and positives. But to simulate a large-scale retrieval scenario, we appended 100 million images from a popular dataset, the YFCC, the Yahoo 100 million images. Okay, so we had our own images and concatenated the two sets. And then we started evaluating retrieval. And here we see actually this is the ranking of a retrieval approach. And the query, first top ranked image, second top ranked, here's the similarity, so we rank based on similarity in the second row, third row. So what we see, and what is
Okay.
the color coding here? So green is the positive, the others are negatives. The red ones come from the 100 million images. Actually here it says 1 million subset, okay? Now the yellow ones they're negatives, but they come from other images that we collected for our small data set. And there is just 1,000 of them. So, this means that this was another object in our data set, and that was another object in our data set. And now the surprising part is that in the data set, the ratio of yellow to red is 0.1%. We have let's say 1,000 yellow ones, but 1 million red ones. But we see that in the top ranked images, the ratio of yellow ones is significantly higher. We kept retrieving, in the top ranked images, the ones
Yeah.
from the set that we had collected. And now let's go into details. Okay,
Okay.
Seth, ask.
Let me understand if I get it right. So the green ones are the correct retrieval. The yellow one are wrong retrieval, but still coming from your own gathered datasets. And then the red one are wrong retrieval, but coming from other
Yes, and the
datasets.
key thing here is that the proportion of yellow over everything is 0.1%
Yeah.
in the data set, but here you
Yes.
obviously see that it's a lot
A
of yellow,
lot of yellow.
significantly higher. So now let's go in the details of the data sets. Yahoo FCC was crawled from Flickr in 2014. Okay, our dataset was collected 2 years ago, at least that version of the dataset, because many things changed later, mainly with modern smartphones. That's one thing, okay, that's one discrepancy. And the other is that, well, apparently there was different processing before images were saved, things that we don't know about what Flickr was doing, the image processing. And also something that we noticed difference is in the JPEG compression. And we started to think, okay, something must be there. Of course, we had ways to improve that for this other project and the dataset that we were creating. Yeah, we started to use different cameras. We reprocessed images the same way. We saved them with the same JPEG compression. Okay, but it was pretty clear that there's something there that is worth studying more.
Yep.
And now we can move to our first paper of the series. That was the ICCV. What we see here, that at a glance it gives an idea about what is happening. That metadata seem to play a role and affect the visual representation of the images. Now maybe it's good time to mention that in the previous example we had a foundational model. I don't recall exactly which one was that. You can imagine it was maybe a clip model, pre-trained, frozen. We just use it to obtain a global image descriptor. So the whole image is represented by a single vector representation, the CLS token of a VIT. Okay? So it became pretty clear that there must be something that is encoded from the metadata in the representation space. And now here is an experiment that plots the distribution of pairwise similarities. So we get again the clip representation, we compute cosine similarities between pairs of images, okay? And we do that for the blue distribution, which are pairs of images from images that they have the same semantic label, photos of, like a chair, photos of a table, and same metadata. Metadata in this case, okay, I will talk about more types of metadata later, is the JPEG quality, yeah, that is used while storing the image. So they were saved with the same JPEG quality. Then we take the same
Hmm.
images and compute the pairwise similarities, but we store one image of the pair with different JPEG quality. So same semantic label in the pair, but different metadata label. And we see how the distribution shifts of the similarities. To the left, the 2 points in the representation space move a bit apart consistently, yeah, because the whole distribution shifts, just because we change the JPEG compression. And now you
So let me understand. So you take the same image and then you change the preprocessing. And in this preprocessing, we mean JPEG compression quality. And just changing the JPEG compression quality, you see the difference between like this displacement in the embedding space of your foundation model. So the similarity between query and the retrieved image
exactly,
changes.
it's identical image, we just save it with a different JPEG compression quality.
So and this shift is the shift between the blue distribution and the green distribution, right? So we see this major shift is only caused by metadata, not semantic. Now to the orange one, which luckily for us is larger, it's a semantic.
Exactly, yeah. So while the shift is larger, but you see that the overlap is changing, right? Of course, like when you have
Mhm.
the negative pairs due to semantics, it shifts a lot, but
Yeah,
it really affects the overlap. Actually, it's quite different if you have
yeah,
the overlap between uh, blue and orange, yeah, or green and orange. So the overlap increases significantly. Okay, maybe we
mhm,
can see also another qualitative here example, which is actually it's a real example. Now you have a query, you query with this image, the compression quality is
mhm,
75. Hmm? And here we see that a
mhm.
positive image, an image from the same class, that has the same compression quality is retrieved first. The other two are negatives and they also
Yeah,
have different compression quality. Indeed, that was the way they were ranked, okay? It's not picked by hand. And now, what we
yeah,
change here is that the negatives have the same JPEG quality as the query and the positive has different, and the ranking changes. Yeah, this is ranked by cosine similarity. Okay?
right.
So,
Yeah. So we retrieve the wrong image, even though our image with different semantics, just because there is similar compression quality, and then the model therefore value that more than the semantic itself.
right. Okay, and then we started to systematically study that for two types of metadata. Okay? Maybe you can see where this is heading because of the example I gave from the very first screenshot of the retrieval dataset. And was what we call image processing metadata, processing operations of the image like the JPEG compression, a sharpening operation, the interpolation algorithm that we use when we resize an image. Okay? And acquisition metadata that have to do with the acquisition process. So things like the camera model that was used, exposure time, aperture size, and so on. Okay. And each time we have like a set of categorical labels for that. Like we pick discretely 6 values for the JPEG quality, for example. Okay. Or we have 88 camera models in the dataset. And maybe just to not cause confusion, there are different ways that we affect that. Like for the processing, we can process exactly the same images with different uh, values of this parameters. Okay, you change the sharpening amount. But for the acquisition, that's not possible. Okay? So here we synthetically create labels
Yeah.
ourselves, but here that was not possible, so we had uh, to download the dataset from Flickr and use EXIF data. Okay,
Okay.
and let's see how to systematically study that now. So, first experiment that we did said, okay, if something from the metadata is encoded in the representation space, you should be able, from this frozen backbone and the representation, to predict the metadata labels with simple linear classifier and frozen
Yeah.
representation. And we did this for tons of different models. Here, like every bar in this bar plot is a different foundational model, and we have contrastive vision language models like CLIP, fully supervised on ImageNet, and self-supervised like Dino. And you see that, well, pretty much for all the cases, the accuracy in doing that is higher than random chance. This is 1/6, okay? I remind you that we picked to have 6 values for the JPEG quality.
So it's essentially very easy for a simple linear probe applied on the embedding of the foundation model to predict the metadata that the image has been acquired with. And this, I mean, of course, is not necessarily negative, but it's interesting how
Yeah,
easy it
and
is.
like significantly easy for some of the models. And we see some patterns also here that the orange bars are typically higher than other bars. The blue bars are typically a bit smaller. Of course, like here we're mixing also models of different of different size.
Sides.
And of course, this is not
Yeah.
completely new, right? Like this has been in the literature. Just now we start to study it more systematically for this particular type of metadata and for lots of different models. And
Yep.
well, we did the same for the acquisition ones. Like now it's the make, what is the company that produces the camera, exposure, and so on. Always significantly higher than random chance.
Okay, so these are acquisition metadata, which you cannot change afterward. Before we had more like processing metadata. Here, like the ISP, for example, or interpolation. While here we have something that depends on how the image was acquired in the first place. So these cannot be changed once the
Yes,
image is
just to
acquired.
understand maybe a difference between the two experiments is that here we can have on the left, we can have every image assigned to all different classes because we process it again, and we do, while here
Sure.
every image is assigned to one of the classes for a
Okay.
particular attribute like exposure.
Yeah.
Okay,
Yeah, of
so this
course.
is crystal clear, right? They have the ability to invert the metadata label, some of them significantly higher, and there is a pattern, okay? Why vision language models more than self-supervised? And of course, I'm going to come back to this again and again. But then, what is more important is, okay, maybe I can move maybe this poster, okay? What is more important is that we wanted to study how much, no, this kind of shift of the, offset of the representation points can distract the semantic prediction ability of the model. Because maybe someone would say, fine, you can invert, that's interesting, can be interesting property, yeah? But as long as it doesn't distract the semantic prediction
Yeah,
ability, yeah? Which we have seen
exactly.
already from the qualitative results that it does. But how did we study this
True,
more
true.
systematically? So we created now synthetically for the processing case, for the image processing attributes, case that we have a nearest neighbor classifier, and we query with an image, and all the other images are with the same JPEG quality, let's say JPEG for example. Now in the second case, the positive is with the same JPEG quality, all the negatives are with different JPEG quality. And in the bottom case, third is the other way around. So if metadata labels play a role to bring, say metadata brings images closer, the second case will help, the Kennan classifier actually to give a correct prediction, but the third one should distract. And you see these arrows. Actually, these three cases are plotted here. Again.
Okay, so
Yeah.
let me see if I get this right. So in the first case, it's more like a baseline where we impose the same metadata on both positive and negative. When you say positive, we mean same semantics. The negative is
And I
different
didn't clarify
semantic, right?
something. Now the classification task, we have a nearest neighbor classifier. The classification task is about the semantic labels, okay?
Yeah, so we try to, I want to find
Yeah.
other flowers of the same breed of flowers, so to say, right? So in one case, we help it, or we, based on our guess, I get, we try to help it by giving kind of a hint, saying like, you know what, all the other the correct flower will have the same compression. If it's in the second case, like when the arrow is down, we give the same compression to different flowers, but the right flowers, the one that we're looking for, the same flower as the query, will have a different compression.
Yeah.
Am I seeing this right?
Correct.
Okay.
And now what we plot here is on the right. The bar is for the first case. The top triangle is for the second case. The bottom triangle is for the third. And let's see how that looks for JPEG. Okay. So if the distance between the two triangles is large, it means that metadata played a significant role. The predictions were significantly different and the accuracy itself varied a lot. And this happens indeed like for the vision language models. We see like big offsets between the two triangles and very small offsets for the case of Dino and self-supervised learning. So a bit of a similar pattern, like before, the orange ones were better able to invert the metadata label to predict it. Again, here, these are the most distracted ones.
Yeah. So, because of course, if the metadata was absolutely, like if the model was agnostic to the metadata, then the two arrows would collapse, because the model would just say like we as humans, I see these flowers, I really don't care about the metadata, so I'm totally agnostic to it. You will not see my prediction any difference between the settings.
Right, and the difference in some cases are striking. You have a model here that was around 75, and then like it goes to 85 or below 60. Significant.
Yeah. So it means that the model is basically looking at the metadata in even more maybe, or like with a similar weight to the actual semantic class.
And things like Dino pretty much close to invariant. And of course, on the left, why is this happening? Like the metadata, they're encoded in the representation space, but of course, I would think that something is encoded in the image space on the pixel level. Like there is something that doesn't have any semantic meaning. It's like a low, as we call it, low-level signal. It's a signal at the level of pixels, and something that is not even cannot be perceived by the human eye in most of the cases. Well, maybe very briefly, I would say that we had a similar experiment about distracting the semantic prediction ability for the acquisition case. There we had to collect our own dataset, and how we did it is that we took photos of the same object, trying to keep light in and the viewpoint as close as possible, once with a modern smartphone and another with an older compact camera. And if I go here, indeed, this is what was happening. So you query with this guy here, and that's the retrieval if all images in the database are taken with a smartphone, which is different than the camera of the query. But now if I change the camera only for the negatives and use the same old school camera as the query, these are ranked first. And again, this is not made by hand, it is the actual ranking. And we systematically studied that, and we observed, a similar pattern. That some models get distracted much more than others. The usual suspect is again the orange guys, the vision.
The orange guys. Yeah.
So, in this work, it was making it clear that something is encoded in the representation space, and this is entangled, like is affecting the
Hmm.
semantic prediction.
So from this, basically, I think this is really interesting because we always relied on these big foundation models as if they're a bit oracles sometimes, because we always assume they're trained on so much data and such a large volume that they kind of should marginalize out the. I mean, that's when I'm saying what we hope, right? We in the community, like many times we use Clip or these others, and then we just hope that they are so over parameterized and they're trained on so many millions, billions of images that they are like, absolutely, they should marginalize out every potential spurious
Mhm.
correlation. And then we find out that it's not the case. And then the metadata actually are extremely, like they're still extremely sensitive to metadata. And that's what, I mean, as you said, it's okay, the fact that you can predict it, but the fact that we have such a big displacement in the embedding space that could cause performance degradation, that's absolutely not
Right.
not welcome,
and,
I would
and
say.
you already mentioned a keyword, correlations, spurious
Hmm.
correlations. Okay? And that's
Yeah.
where it's all heading, and that's what we do in the second piece of work, right? Why is this happening? Why do the models become sensitive to metadata and the pixel level signal or noise? You can call it as you like based on the context. Uh, and we assume that the reason are the correlations between metadata and semantic labels, or the supervision signal, you can call it, in the training set. And such correlations, or correlations in general, have been shown to result into shortcut learning. That the network, instead of like minimizing your loss for the expected or the correct reasons, finds a shortcut, constructs, captures some easier, simpler features, and it minimizes the loss.
Yeah, right. I remember that the easiest case for this was like if I have to classify a boat, it's much easier for me to just find an image with a lot of blue because that's probably like a sea. And then if I can classify the sea, that 90% that the object is gonna be a boat and not gonna be a cat or like a or something
Mhm.
else. So yeah, I learn like I will not learn what the boat look like, but I will try to learn, like I will just get that there is a lot to like what the sea look like. Or maybe if I have to classify a cat, rather than looking at the shape of the cat, I will just learn for like the texture of the fur of the cat, or maybe which color cats might look like. And then if I have then another representation, then it's kind of I'm learning features which are not like the problem of these features is like they don't translate well when you change deployment domain or you change stuff.
Yeah, actually, no. There's an interesting discussion whether we should be calling them spurious or not,
Mm,
or when are they spurious and when are they useful correlations. The useful example is
indeed,
the
excellent.
cow and the grass. Like we always observe, cows on top of grass, and if you observe it then on snow, the classifier will fail or will have a lower accuracy. I think maybe what is good to keep in mind, it's all about the prior distribution, the training prior and the testing prior. Because like if these are matching, yeah, maybe it's useful to capture the correlations.
Hmm.
They're not spurious. If always you
I get
observe
you.
cows on grass, capture the relation between the cow and the grass, and this will help you have a higher test time accuracy. But you're assuming that the prior is the same. But if the
Yeah.
prior changes during test time, then you're screwed if you don't ignore this correlation. And that happens also, in what I'm going to talk about now. I mean, that's relevant.
Hmm.
So we hypothesize
Okay.
that these are the correlations that cause the problem. Okay. Uh, for example, we go on ImageNet, and we uh, plot here a histogram of JPEG quality of the ImageNet images. And the black one is the overall distribution. Okay? But then we see, oh, for some classes, actually, the distribution is noticeably different than the global and noticeably different across the two different classes because of the repositories that these images were downloaded from, for example. Okay. Uh, and well, the case of clip is a bit different, yeah? But we try to prove our point by taking
Mm-hmm.
captions and their embeddings and doing some kind of topic modeling. Yeah, you can see it as clustering, so that we cluster images that are related to particular topic. And then we see the distribution of the metadata labels for different topics. And then you can see the focal length here. The overall again is the black, and then you see, oh, bird watching. You have this beast lens, yeah.
Mm-hmm.
There are focal length to do that, and that's expected
Yes.
and that's observed. But for some outdoors, I don't know, like building photos, you don't have that. The same for apertures. So indeed, here is a good evidence, small evidence or small evidence. Maybe you can say that correlations, of course, do exist. And now we have the hypothesis. So are they
Mm-hmm.
captured? During large-scale training. Maybe that's a new thing. That's about very large. Yeah.
So yeah. In the data set, we see that in the data set, these correlations are really strong sometimes. For example, like I'm looking at both the exposure time, for example, for sport, pictures for birds, like this is like predominantly like when every time that you have a picture of a bird, basically it's always with a super long
Mm-hmm.
focal length. So okay, so now the question is, can how much would that degrade the quality of my prediction of the semantics if then I change the focal length? That's kind of
Yes, exactly. And what can we do about it? It's a tricky task, right? Of course, we're talking about in
mm,
some cases super
yeah,
large scale training, right? Heads up
yeah, of
information, we
course.
didn't repeat clip training on 5 billion images in this paper.
Yeah. Also because we don't want to break biases, which might actually be great. Like some biases are great to keep, so it's not, and then we cannot even do it in a way that is kind of custom and handcrafted, right? Because it
Yeah.
doesn't scale. Otherwise, for every semantic class or metadata, we have to do some kind of anonymization or right of this class that doesn't apply.
Okay, and let's see now, what we did, because, maybe there's many things that are tough to do here, but just to bridge
Hmm.
the gap, because this is experimentally heavy, now we give two different code words, to the accuracy of the different experiments. So for this one, we call it metadata prediction ability. We will see this abbreviated as MP, metadata prediction. And this is because about distraction is like semantic prediction distraction, yeah, SPD, MP, SPD. Okay, semantic distraction and metadata prediction ability. So we studied these two things again. But to put this in one number, we monitor the difference between the two triangles. Yeah, close to zero, it means almost invariant. The larger means that it's more affected. Uh, and the first thing that we did is we went to models pre-trained on Imagen 1K and on Imagen 21K. And actually we measured the correlations between JPEG quality and the semantic labels for those two, as this is given by Kramer's V measure, like an appropriate measure for measuring that between nominal variables. And we see that, okay, that's not so
Hmm.
intuitive, but at least relatively on 21K it is larger, more correlations on 21K. And then we measure, oh, here, green is 1K, blue is 21K. Higher MP, metadata prediction ability. It's the blue ones better able to invert the metadata label. For different backbones, it's consistent. Whether it's aperture, whether it's JPEG. Okay? And here,
Hmm.
how much they get distracted, again, the blue ones get more distracted, so they're more sensitive. It seems that indeed, like that's the first hint that on 21K, because of higher correlations, there was some amount of shortcut learning, and it made this backbone more sensitive to metadata. Okay, and what comes
Yeah.
next? The problem is here is that it becomes more difficult to decrease the correlations, yeah, than to increase the correlations. So we increase the correlations to prove our point. Yeah.
Okay.
So this is what happened here, and we work with JPEG first because it's easy. We synthetically create our labels. We save again with different JPEG compression. And the experiment here says that okay, I will assign every imaged class to one JPEG label. Now playing with quality and the chroma sampling, I forgot the number, 30 something, maybe around 30 discrete labels, okay, for JPEG quality. And I assign one semantic class to one label. And there is a probability here whether we will use this JPEG compression for one image or not, from 0 to 100. So 0 means we're not reprocessing any image, and we're exactly as the origin. No, sorry. Uh,
So I understand. So you remove it even from the image that I took
sorry?
previously. So like what I see here is that you say that all birds, for example, now will have this JPEG quality. All
Yeah.
like I take another class, all cats
Yes.
will have this other JPEG quality. So you kind of
Sorry, yeah, say,
Hmm?
go ahead.
No, please keep going. Like I'm trying
That's
to
exactly
understand
it. So in
what it is.
100% here, all the bird images will get the same.
Yeah.
And all the dog images will get different. In 50%, all, half of the dog images will get that, and half of the others will get this, while all the others will have some constant JPEG. Okay? And in 0, everything will have the same JPEG. And in 1, this is the
Yeah.
original image.
Okay.
Okay. So here,
Yes.
what do we see? I mean, the pattern is clear. Higher correlations, much better ability to predict metadata. No correlations no correlations for JPEG, right? We're not controlling other things. We're controlling only JPEG. There's other correlations that we're not touching. No correlations, the lowest ability. Original image a bit higher because it has some correlations. Yeah? And the same pattern for the distraction amount. Okay? Let me know. I can imagine maybe that's not easy to digest on the fly.
So give me. I don't get the colors here. What are the blue
What are
ones
the
and what
purple
are
ones? I
the?
didn't talk about the purple ones yet. Okay. Yeah.
Okay. So no. I mean these. So okay. Here we have.
Ah,
So these 4 plots on the
okay.
top. Here we talk about acquisition. Okay. Okay. This we talk about acquisition, and we have MPP, which is the
I see.
metadata
You mean about the
prediction, right?
background color of the figures? On the top is the
Yes.
metadata prediction.
Yes.
Okay, can I invert the metadata label either in
Okay.
processing here
Okay.
and there, or acquisition here and there? And at the bottom is the semantic prediction distraction. How much do I get affected? If
Okay.
if
Okay.
the how much I get affected? Yeah. Okay.
Okay.
In the synthetic experiment that we were describing in the previous paper, yeah, with the 2 triangles. So we have it's extreme situations. We're changing,
Yes.
the JPEG labels during test time.
So what is the conclusion that we see here when it comes to the semantic prediction
Well,
destruction
this is
in this
evidence
case?
that indeed at this scale, even at image level scaling, the network is able to rely
Yeah.
on the correlations between such.
Okay. So basically, we prove that shortcut is possible. Like it kind of the model. If you give a way to exploit a shortcut, the model will
Even for cases that
immediately
are
learn it.
invisible shortcuts, there are, like pixel level, maybe things in the frequency domain, like maybe there is a line of work that studies shortcuts in the frequency domain, not necessarily through metadata as we do, but yeah.
Yeah. Okay.
And maybe now, no, before I go to the case of there is a lot more to talk about here, but okay, one remaining thing is to talk. Okay, can we mitigate this to some extent? Can we do something? Because it can be a problem, right? And how actually we said that it can be a problem when the distribution changes during test time, as we were saying before, when they start to become spurious correlations. Here actually we see
Hmm.
the ability of the network to predict ImageNet labels. So we go back to the original ImageNet task, because when shortcut learning happens, uh, the model starts to capture the shortcut and not actually what it should be capturing. And we see here, if you focus here, okay, on the green bars, indeed for 100% case, the accuracy, the ImageNet accuracy dropped noticeably, because it was captured, the network was capturing shortcuts. Okay, and this is the green one is about we evaluate on the original ImageNet. But if you would evaluate on a test version on ImageNet that has the same correlations as the training, which is the purple, of course performance is much higher because now capturing the shortcut pays back.
Hmm.
So the green one says, yeah, okay, that's a problem. It's worth trying to fix it. And it's a problem when there is a difference between the prior distribution between training and testing. If they match, purple one is not a problem. Okay, there are also other cases actually in the
Yeah.
literature that they don't relate to our findings yet, but this has been a bless and not a problem. This has been a help. And there are examples in the literature of detecting generated images from stable diffusion. People need a binary classifier. Is this real or is this generated? And there were examples of people relying on
Yeah.
frozen clip representation to do that. The first results were just doing a Cannon classifier with frozen clip, and clip was a game changer. Okay,
Hmm.
why was it a game changer? Because
Yeah.
it captures something at the pixel level. It captures some signal that is very low level. If it didn't capture, if it was only capturing semantics, the
Yeah.
nearest neighbor classifier wouldn't work for real versus generated. The nearest neighbor classifier would be purely working on semantics. But it seems that it also retrieves based on some
Yeah.
low-level information. And my understanding is that okay, some time ago, when people were doing detection of generated images, they were trying to capture wrong semantics. Okay, so some time ago it was the 5 fingers, yeah, of it's not there anymore. And I think it's
Yeah. Of
about the
course.
low-level signal that changes. And you want you want to rely on a model that captures a low-level signal. And apparently CLIP, which in our previous work we saw that it's one of the most sensitive, it is the most sensitive because it captured low-level signal that is a result of correlations between metadata and semantic labels.
Use at all. Why is Clip compared to Dino or others so extremely sensitive to that? Is it the contested learning losses because of the language prior,
Okay, good
or
point. Good
what
point.
is the?
Now we go, we can revisit the findings from the earlier paper, yeah, and the hypothesis about shortcut
Mhm.
learning. Shortcut learning is possible when there is a correlation between supervision signal and metadata. And actually, you have semantic labels on image, and you have caption labels on line. Self-supervision you don't
Mhm.
have, and maybe that explains why something like Dino v Dino, all the versions of Dino are less sensitive.
Yeah.
Yeah, because there's no such semantic to metadata correlations. There are images and there are line. And apparently, okay, it's not easy to quantify, which is stronger and to what extent the model captures it, but there is also a side explanation.
Mhm.
Unfortunately, the researchers that were training clip on Lion for a reason, maybe because there are no epochs in Lion. You don't revisit the same image again and again. On images you do, and augmentations are a standard thing. You augment an image again and again. Online, people thought, okay, we
Okay.
will not revisit any image again. We have 5 billion images. Maybe there's no need to do augmentations. And we have some experiments that we show that if you augment an image, specifically with things like resizing, yeah, or color jittering, the
Mhm.
sensitivity decreases. Why is that? Okay, it all clicks with the hypothesis that because it kills the low-level signal, it kills the signal that is lying at the pixel level. So that
Okay. So you think this is so what you're telling me it is it's funny because this is us you're saying that the reason why clip is more sensitive is as it once more a spurious correlation because on how we train this foundation model, not of the foundation model itself. There is like people that train clip. It's not the problem of the contrastive loss or the fact that there is language captions in the picture, but your hypothesis is that these people that train clip they were not
no,
applying good
it is a function of
uh,
all these things, yeah, both are correlated, but
all
they
these things
missed the
together.
chance to
Okay,
kill
okay,
the
okay.
signal, to kill the shortcut. That's what
I see.
I'm saying. By Dino, it's not about just the augmentations, but they're more extreme. Yeah, in self-supervised learning by instant discrimination, you rely on a lot of augmentations. And here the experiment shows that okay,
Mm,
maybe we can see things like here. You have all the Dino augmentations here. You know, it goes
yeah.
from blue to that. Okay, sorry. Sometimes I'm moving my cursor as if I'm sharing my screen, and I think this doesn't work. Yeah, now
But
I'm
I see, oh,
clicking,
no,
now I'm
I
clicking,
can
so it
see
goes
your
from
cursor.
here to
Yeah, so,
there, hmm? Or from here to
yep.
there. Okay. So there is
Mm-hmm.
evidence also about that some processing kills. You do resizing. There is interpolation between nearby pixels there, and that kind of like kills that signal to some extent.
Mm-hmm. Mm-hmm. Okay. So essentially, it is okay. So we see that so this is the impact of augmentations. What you're saying right now.
Sorry, this is as you say.
So here we see the impact of augmentations in. Okay, okay, okay.
Yes,
Yep.
yes. So this was
Mm,
just of course like just ResNet 50 and done on ImageNet, but we have also actually already from the first
mm-hmm.
paper that okay, I don't need to show it, but I can say that we either fine-tune clip, we do a few more rounds while
Mm-hmm.
we include augmentations, and we saw the sensitivity dropping, or we can clip from scratch. It's just that we didn't
Okay.
do the beast model, yeah. So the performance was lower, and we did it
Yeah,
twice,
of
with and
course.
without augmentations, and again we observed that sensitivity was smaller.
Okay. And do you see that does it reach the same level of Dino, or you think it's so? Do we still see if we trained Clip and Dino with the same augmentations? Do we still see a difference because of the
Of the
objective
correlation
functions?
between
Okay.
supervision signal and metadata. That's still the hypothesis
Mm.
that somehow has some evidence to verification. So still, it's not
Mm.
enough. It doesn't mean that it fixed the problems of Clip or ImageNet,
Yeah.
but it is a way. So this is like kind of, we try to understand, yeah? Understand, maybe give some solutions,
Yeah.
but it's
Yeah.
more about the understanding of what is happening, not like maybe game changer solutions. And that was one that you can do during
Mm-hmm.
the
Mm-hmm.
training. Then we have another mitigation where if you have an already trained network, actually we're trying to use metadata labels and some adversarial training scheme to learn a projection of the original space to reduce the sensitivity. So that would be the adversarial is, oh, I have a classifier that predicts metadata labels. Now learn your your feature transformation so that it distracts this classifier. That's the adversarial part. And we see here that
Okay.
with this mitigation, so that's here we see it is before mitigation like this, after mitigation like that, so left and right plots, and we see that actually the ones that were
Mm-hmm.
distracted the most are helped the most. So this was significantly distracted. Actually, convex for a reason is the most sensitive one in all our experiments. So with this mitigation, the sensitivity dropped a lot.
Mm-hmm.
So yeah, the context here is take the
Yeah.
frozen backbone and learn just the transformation of the linear layer and learn it so that it's close to what it was doing before, but also try to full the classifier that predicts metadata label. And all the importance here is that, oh, we do this with JPEG metadata because we can synthetically create them, but it reduces the distraction even to camera metadata, which is a verification that all these
Yeah,
metadata kind of indeed leave a low level footprint, like a pixel level footprint.
yeah. This is, I think, this reminds me a lot. Do you know there was this paper it was a super old paper from Gunn in 2016 or something. I think it's called Adversarial Training of Neural Network. It was very similar to GANs at the time, where were actually trying to anonymize a latent space by having an adversarial component, uh, just trying to get like the goal of this adversarial loss embedded that was targeting a latent representation of a model was trying to regress if that latent space was coming from the source domain or the target domain. And if this adversarial component was able to do it, then there was, of course, a co-adversarial loss targeting the that latent space and therefore everything before and the encoder. And then what they proved that this was a very efficient way to essentially anonymize the latent space by training, keep training for a specific task, but also trying to keep this latent space anonymous from the source domain. In that case, there were only two source domains. In your case, you are like want to remove the sensitivity to the camera parameter or the metadata, which could be seen as different domains, data domains,
Yeah, it seems
right?
technically very similar, and actually our formulation technically is very similar to many other things out there. More about the finding and the
Mm-hmm.
message that, oh, we can mitigate that even after training. And more importantly, we use
Yeah,
JPEG labels to mitigate it, but we improve also for other labels. So there is some common pattern that is triggering all the problems.
yeah, interesting. And indeed, in one of the things that I mean, the only risk that I see doing that, and I think you have evaluated it, is how much performance you lose by enforcing this
Oh
metadata
yeah, yeah,
anonymization.
definitely. Yeah, here you can see this. This is actually, it is in this green part. Which is the drop
Mm-hmm.
from left to right. Surprising, there is even like a small rise
Yeah,
now. Maybe it's tough to interpret. Maybe that's not so significant if we repeat the experiment
yeah.
10 times. But at least like around the same levels. Yeah, it's around the
Okay.
same level. We do this in the other
Mm-hmm.
mitigation, and
Okay.
indeed, for the augmentations, you do observe that you compromise something. Yeah.
So here, what I read is that basically by breaking these biases, you generally don't have a performance drop. In some cases, you might even go beyond that because maybe beforehand, these biases were actually hitting you in the back, and now that you break them, maybe your model can actually look at the semantics better and therefore get a better results. So
Actually, you are right that especially for the orange ones, maybe that's the interpretation here because these are the ones that were affected the most. So it can be that they captured the shortcut so
exactly.
much that the semantic prediction, SP accuracy was
Yeah.
is harmed the most. Yeah.
Okay. So there's also time for question now. I think we are almost run out of time, but we can keep the discussion also in the let's
Okay.
see in Discord. But if there's any question, we can take them now, I guess. Unless do you have any
Until
maybe final
any question
result
come,
on
I will
your
just say
experiment?
that we did verify indeed the usefulness of capturing shortcuts, the usefulness into detecting generated images by doing an experiment
Oh
that
yeah.
indeed like, oh, we retrained by sorry, that's not it, it's but that's also important. Okay, well,
Hmm.
now I'm mixing up probably it's in text in numbers in the text, but we observed that training on increased
Okay.
correlations made the frozen network better able to detect generated images. There was a noticeable jump of performance. Uh, Other
Okay.
useful things that I didn't manage to talk about is that, okay, actually we're improving this now. We even managed to increase the correlations on a subset of Lion. and we saw that indeed clip, behaves similarly when we increase the correlations by sampling images in an appropriate way. Yeah? Now this appropriate needs explanations.
Hmm. But I have a question when it comes to detecting generated images. I mean, how reliably can we exploit the metadata? Because there are two cases. What if is it possible for the diffusion model generating fake images to, if prompted correctly, or just becoming better and better, to, as an emergent property, to start learning also invisible property? Like it could start to learn invisible shortcut itself, right? It could learn how to reproduce so well that it will, like, first of all, as an emergent property. And the second one is that if I really want to create a fake image that is not going to get detected, then I can apply the same adversarial process that you are applying, so that I will be able to
I mean,
reproduce the metadata
I
in my
mean,
generation.
definitely. For me, the next step is that indeed, with some colleagues, we're focusing on that. Is like, try to capture the noise. Yeah, maybe capture the shortcut so that you will be better able to detect. But again, adversarially, you're correct that maybe a generator will try to fool this generator now, because
Mm.
it is the pixel level signal that
Yeah,
is remaining. Semantics are fixed. In semantics, they're very
yeah.
good.
Hmm. Yeah, I mean, that's the same for language, right? Like I don't know if, do you see a way that is there any metadata? Like, for example, maybe the acquisition metadata is, or no, maybe not even true, but I don't know. Is there any metadata that you think it's harder for diffusion model to copy? I'm thinking about if I want to generate fake images that cannot be easily.
Uh, well, I will comment in a different way, because yeah, when you mentioned that, is interesting that we thought that we can have a training set without any correlations if we use generated
Yeah.
images, because some people indeed use diffusion models to create a new image net from the same 1000 classes, and retrain models. There is a line of work like that. We thought if we take those, they will not have correlations. But our hypothesis failed, and it seems,
Mhm.
okay, that's ongoing. It seems that it failed because some amount of low-level signal they have imitated. They're able to reproduce it. Oh, yeah, exactly.
Wow. Okay. And and this was as an emergent property, basically, because no one, of course, asked for that to be reproduced, but then it's coming either through the, I don't know, the VIE that has been trained with some adversarial loss, or maybe just picked up naturally, or what do you think?
I don't know much to say. It's like actually it's quite exciting indeed to
Okay.
dig more into that. And
Okay.
maybe I'm not really an expert in this field, and I think like maybe things are out there already in investigating that. So for us, like it's a side thing that we haven't managed to dig more into.
Okay. All right. So I guess there's no further questions. So, and we've reached the 1 hour mark.
On my side, because we
So
jumped too fast
I
to the
guess,
technical part, and I missed saying that this has been a collaboration between researchers at CTU in Prague and
of
Osaka
course.
University, and that's actually the whole how to say list of collaborators and authors of this work that were attending ICCV a few months ago.
Yeah. All right. Okay, so thank you so much, Yorgos. It was super interesting, and there's so much that still I have to ask, like all the implication when this come to domain adaptation, and how, for example, the model could adapt to these parameters maybe online, and how like to break these biases, or what biases to keep, and for fake detection, etc. It's super interesting. I really wish there will be more of these. I mean, to have you back in the research club, you and your group, of course. Also to see where this whole field will be moving. But I guess for today we covered quite a lot of stuff already. So thank you again, and see you all next time. And maybe I can even mention next time we'll be talking about robotics manipulation and new ways of uh, entering in the robotics manipulation world. All right. Thank you so much. And then see you guys next time.
Thank you, Pierre, for
Bye,
the
everyone.
discussion and for inviting and organizing that. Thanks, everyone.
Hello, everybody. Good evening, good afternoon, good morning. How are you all doing? Can I have, how are you all doing in the chat? How are you all doing? Good, bad, okay, amazing, amazing. Outskilling, somebody is saying outskilling. Great, great to see that. Amazing, amazing, amazing. Okay, amazing, folks. Amazing. Great. So I hope you all have started building the products for the hackathon. And since we are talking about it, welcome to AI Builders Hackathon by OpenAI in partnership with Outskill. This is where we want you to build, ship, and launch the product. Right? This is a platform that is there for you all to go ahead and literally make the product go live within 7 days, and this is what we are all here for. Today is going to be our session number 1. For the same, we are going to see few things around uh, how you can improve your MVP, how you can incorporate codex better into your MVP, and what all things are gonna be there. So, but before that, I want to know how many of you are there who have started building and are very sure that they are going to deploy the best product possible. Can I have me in the chat if you all if you see that yes, you are gonna be able to do that? Amazing, amazing. Amazing. Already deployed. How great. Great. So, folks, there are few things that we have already done. We have shared a few communications with all of you, which we would want all of you to have a very read it properly, follow the instruction carefully. We have shared you a daily update form which needs to be filled. That's a mandatory thing for today. Today is your end of phase 1, and that is where we are having this session. So please make sure that you are not just missing out on this important checkpoint. We need you to submit your MVPs today. Today's session will help you understand few things if you have been stuck somewhere. So don't worry, we are going to come up to that. But make sure you do it today. 11:59 p.m. IST is the deadline for all of us to submit their first phase MVP. Now, going ahead, we are having an amazing, amazing session today. We are going to talk about Tech 101, how you can use your tech stack better, how you can incorporate codecs better. There are few things that we are going to cover over here in today's session, and um, that is where we are all here for. We have an amazing, amazing person coming in to talk about these things. And we have King Siddharth coming in. He's the head of design and product at Outscale. He is somebody uh, who has been deploying products, who has been building product for longest of the time, and somebody who knows how to get things done when it comes to building products and deploying them. So we will be having Siddharth coming in. Drop boom in the chat so that I can call him in and we can directly jump into today's session. Drop boom in the chat so that I can call him in. Amazing. Great. Great. Hello, Siddharth. Good evening. How are you doing?
I'm doing well. I hope everyone is doing well as well, and super excited to get started.
Amazing. So that I will not take any further time, folks. Make sure you focus well. We are going to have like 1 hour 15 minutes of teaching, and then we'll be taking few questions as well. Siddharth is going to be there to help you out, and he's gonna tell you how you can do things for the next 3 days. So don't worry on that part. Make sure to be respectful. Don't spam in the chat, and Siddharth, I think that is where I'll hand it over to you. You can take it up from here.
Awesome. Let's get started. I have much in store for you. I want to show you how I use Codex. It's been my favorite app to build with lately. From MVPs, prototypes to I see that some people were very happy with the glasses. They had to come off, and unfortunately, just AI stuff. So let's get started. And I want to quickly check with you folks. Um, there's a video lag. Can you folks hear me clearly? Let me know. Let me increase the volume a little bit. Is it better? Awesome. Awesome. Voice clear, video lagging. All right. So now, quick question. How many of you come from a tech-ish background? How many of you can code? And from non-tech? Just put any of these three words so I know what you come from. Bro, I'm 17. That's crazy good. Not that age matters much in tech. I mean, maybe it does matter non-tech, tech. Okay. And so that not too many, there's computer engineer. Okay. All right. So there's a mix of people. AI researcher here. Crazy. Non-tech 18, data engineer. Awesome. I'm seeing some first year students, etc. Great that you're here. Happy to see you here. And the best part about building and in general about tech has been the barrier to entry has just been interest and curiosity. So kudos to you folks that you folks are there. I'm going to share my screen and I want to quickly talk about some concepts and I want to show you what we can do with Codex. And it has become my favorite app ever to build with. I will open a whiteboard. This is a whiteboard where I will draw quick things to to communicate. Mostly speaking, when you're building an app, how many of you want to build a web app? What are you building? Can you put in the chat so I understand? What are you building? Are you building an app, mobile app, SaaS, Electron? Okay. Web app. Web app is the easiest to get started. Awesome. PWA. Awesome. SaaS. Okay. Desktop app. More like a tool. EdTech. Amazing. Okay. So let's quickly take a idea of what you folks are talking about and put them in neat categories so we understand what is going on. Those of you who don't know what these words are, don't worry. Let's start with the basics. You can build websites, right? If you're getting started for the first time, you're building something, that's where you can get started or try to build. The next obvious thing to build is web app. Chat GPT. This is, if I open this Chat GPT, this is a web app, right? So that is what web apps do. They're applications, they're apps, but they're on the website. You can put that web app into something called as Electron, and you can ask your Codex agent to build a desktop app. These are the apps that run on your laptops, that run on your Windows machine, that run on Linux machines or Mac. These are desktop apps. And if you use Notion, if you use Slack, these are mostly Electron apps. They are web apps converted into the desktop apps. And of course, you can build mobile apps. There's a way to build them which is closer to this web app zone. And you can also build something known as native mobile apps. All right. This is a range of things you can build. There are a lot of other things that you can build, honestly. For example, did you know, and I was so impressed when Codex was able to do it in my experiments, it could also do apps for things like the smart TVs, smart watch, especially Apple has a great ecosystem if you want to build it, and Codex works great there as well in my testing. And let's say, I don't know how many of you are millennials here. Do you remember those cassettes we used to plug in to play like Contra? And how many of you remember that? Do we build for panels? You can do that as well. Deed and Didar meaning. Okay, you're seeing my chat. I was looking for an Urdu word for something. Yeah, so CD, DVD era, you remember? Did you know Codex can actually build you apps or games? Like it can actually find source code and let you play those games on your laptop. So, revive old technology. It can actually do that. Let's not get distracted though. We're talking about building for hackathon and building fast. And I want to share very, very simple ideas today. Wherever, whatever you're building, okay, use this. And these are some tricks which I have found. I won't call them tricks. I think this is a way of working with AI. And I want to show you today, like from scratch, because I'm that confident on Codex's ability to do things because it's been quite reliable. But there are a few things you have to keep in mind, right? And there are challenges that you will face along the way. And how many of you sometimes get in this zone where, like, I'm asking the AI to do this simple thing, but it's not able to do it? Any of you experience that? Like, this is such a simple request. Just move this from here to here, change this a little bit, and it screws up everything, but it's not able to get that done, right? All the time, right? But that is where I found out the thing that works, because it just happened with me yesterday. And instead of screaming at AI and all those things I used to do or threatening it, I started chatting with Codex. Okay, I was literally chatting with, why did you write code like this? Why did you not fix that? And the answers I got were so mind opening, because I realized that, oh, I thought it just had to do this one job, but I have put some rules in place which it's trying to follow, which makes it complicated. I'll show you all of that. But whenever you start, right, you need, what do you start with? Any ideas? What do you folks start with? It's all about the prompt. Yes, it is definitely, because that's the only thing we give. But how do you write the best prompt? That's what I want to share today as well, especially for Codex. So any of you can give me an idea that I want to start building any of these. What should I start with? A simple and short prompt. Guardrails, okay? Build PRD first. Close. What is PRD for? What is PRD for? Roadmaps, architecture, MD file, okay? So some of you saying SRS first, some of you saying PRD first, some of you saying, DB schema first. I want to tell you that I start with a simple plan first. A simple plan. Okay, you can call that PRD, but it's not technically PRD. And this planning, right? I have two things that I want to share about this planning. Then you can go to PRD, you can go to all of the things. But this, in my opinion, is something that people don't do with their AI, especially with Codex. And Codex is so good at thinking through, certain ideas and chatting with you, that I really encourage this. There are two parts to this. Rule number one is discuss with AI, or in this case, Codex. How many of you have done this? Like, open discussion. Don't build anything. Don't do anything. Just talk to me about this. Plan mode, yes, but even before plan mode, okay? And the second thing I want to give you is my secret. The secret sauce that I believe, helps me build stuff with AI faster than other people have tried, So I want to share a secret framework that can help you achieve. And this secret framework works across AI, especially with Codex, but across the board. But let's start this discussion idea. Here I have Codex app open. I am, you can see a whole bunch of projects that I'm working with. I have a new test app. We are in the new test app. I will click this icon right here to start a new chat. We are landed here. Here you will see a bunch of options. If you're not familiar, this is all the models that are available. One of my favorite is 5.3 Codex, though they are retiring it soon. I like Sparks as well. It is really fast. And if you have enough credits, try fast, you will not go back. But I usually stay on the high, and this is a plan mode. You can see right here, I can switch that off, or I can go here and switch on the plan mode. There's goals as well, pursue goals, which is, I love that new idea. Or you can do shift tab and switch that on and off. I prefer keyboard shortcuts. You can see all the folders and add new projects here. And of course, you can change permissions. All right, so all of those things are available. And you want to open a terminal, you can see right here. Okay, this is the terminal. You can find a browser here. And my favorite part lately has been computer use. I was so excited to show you that one as well. But let's get started with the simple idea. And this is my favorite way of prompt. How should I write the prompt, folks? Can you respond? Okay, somebody's asking. All right. Can you folks tell me what is your favorite way to prompt? I am right on the screen. Should we write the prompt? What should we do? Can you let me know what are we required to provide with today? I think Om can answer that question. Whisper, voice, role and task and experience. Jitin and Satvik, I think you folks are right on spot. My favorite way is audio. There is a record button right here. OpenAI has had this on their chat GPT interface and codex interface for the longest time, even before it was a common norm. And let's start recording. I'm thinking of building a website. And what I wanted to do is I want to be able to have like a bunch of UI and want to see glass morphism. And for that, I'm not sure like what kind of like glass morphism I want. So maybe give me controls on the side on a side panel so I can tweak around settings, etc., and see the effect. What do you think? Like, basically, I want to decide first, on the visual style and what the UI will look like. And at the same time, the goal is to build an app where I can just, upload my photos and, maybe just try to crop it or, downsize it, because usually there is a requirement that you have to submit photos for a particular size. And I want to be able to upload those photos and get it to a target size by resizing whatever it can do, right? But I wanted to have a very nice UI, mobile friendly, and I want to explore all of this UI. So can you help me, help me think through this entire process? What am I aiming for? Because I don't think my thoughts are very clear right now. I purposely gave it very, vague terms, like I am not even clear, it's all over the place, it has a mix of UI and this thing. That I'm doing that on purpose because it's really, really good at asking you questions and helping you think through. And I'm specifically requesting for this. Now, when you're building with AI, I have noticed so many people use long prompts and write them by hand. I have done that. I have multiple prompts written by hand. Okay. But the issue is when they're writing long prompts, they have written one part 1 week ago, and they're writing the second part now. I've read through those prompts, and the prompt have contradictory information because they don't remember what they wrote, even though prompt was written by them. Even if you gave that prompt to a human being, in fact, if you gave that prompt to a human being, the human being is going to be like, what the hell are you talking about? You have no idea. Okay, please clear your mess and come back again. But the AI tries to deliver in those constraints. So that's the first issue. Second issue I noticed is people will use other AI to prompt the AI. And that is like, if you're doing that, just stop. You will actually find AI to be smarter than you give it credit for. Some of what we are working on might be easier to explain if I can show you in a web browser. I can put together mock-up diagram comparison or other visuals as we go. This feature is still new and can be token intensive. Want to try it? I'm like, sure, let's go ahead. And do you see like it's proposing something that I didn't know like it can show me on a web browser. So I'm like, sure, let's do that. Let's go ahead. Let's see what it shows us in the browser. And in between, it's using all the skills that I've loaded. And I highly encourage you to go to this plugin section. They have wonderful list of tools and plugins that are available. I use Linear very frequently. I've been using computer use and Chrome very heavily to allow Codex to test whatever it's building. And there you go, Game Studio, like whole bunch of stuff is available. These plugins you should definitely check out. And on top you have the skills part. And I have created so many of the skills using Codex, using ChatGPT, and then loaded them here from LLM Trainer, which actually works. All the machine learning code that I write is written by Codex at the moment. The only model who was at least GPT 5.5 who has not been. I didn't have to scream at it. That's a big achievement, to be very honest, right? Okay, the visual companion is running here. All right, let's see what is it running. Waiting for the agent to push a screen. First question. Official document passport style photo requirements or for general specific social media profile? Very interesting question. I can continue to use voice, but I will say, photo requirements. So it has inbuilt browser. It can control this, or it can actually take over your browser as well. It can open it there. So if you want that, it can use other apps on your app on your Mac or on your Windows, and it can definitely photo requirement tool. All right. Superpowers brainstorming. Current direction photo requirement tool. Next phase is manual requirements only or built-in presets or manual override. Simple manual stuff for now. New chat as a part of project with preset custom instruction knowledge files. Is this a preset? It's completely new chat. I have nothing in that folder. It's a brand new folder I've created just literally 5 minutes ago because I wanted to show you folks how crazy the exploration powers are, right? And what this is the first time, by the way, it has decided to do this. Usually it will chat and build something on the fly. And I do a lot of these throwaway things. So when you're building your main thing, usually what happens is we start the app. Okay, you will start working on the plan and the main thing. Okay, as we would call it, this is my precious work. Okay, the app with big A. Okay, most people will start here. The issue is you get too attached to this idea. My favorite way is don't have the one main big thing. Okay, start multiple chats, multiple projects instead of this. Do mini prototypes. Okay, do prototype 1, prototype B, right? Prototype C. Like explore in parallel with codecs. And what that allows you to do is it allows you to do lightweight, smaller experiments, and then you can decide, okay, towards your app, how will you build towards a more serious app, right? You can use something called work trees, though they get a little complicated to set up. So I don't want to waste a lot of time there. But for the longest time, Codex has this ability to set up work trees, and it can do that for you. You can talk to it and ask it, how do I set up a work tree, etc. And now it has given me a UI already, and it's asking me what kind of setup do I want, right? And do I want this kind of layout? Do I want that kind of layout? I'm imagining maybe mobile bottom sheet. Maybe this is better. I can select. I will go with this one. I think this is what I want. I think C is what I want. So I let it know. Do you see like it's actually taken my thoughts and is presenting me UI option and building slowly, towards the common shared goal. And usually what I do is start 2, 3 such chats. We can go here and in parallel start a new chat. Brand new chat. It has memory. It has all those features baked in. But right now there is no knowledge in this particular project, and it's completely building that from brand new, like completely from scratch. So that I am 17. What to do? Thinking doing CSC is great in this generation. Please be real and reply. Keshav, unfortunately, the thing is, when I grew up, the options and the world was less crazier. So my advice may not be relevant to what you're facing, right? So I avoid giving advice, especially to Gen Z, because not because because the challenges you folks have to face is just wow, like it's next level crazy. But having said that, I think always curiosity and ability to talk, communicate, show up in places like you have, trying new things has always been the way to success in at least in tech. So I would say, continue to do that. And but I think like every generation, your struggles are unique, so you'll have to kind of figure your own way out. And my advice, like, will be some stale old man talking and yapping about it. But I just shared my thoughts. So do we want crystal light, studio glass, and frosted paper? Folks, which one do you want me to choose? Which one do you want me to choose on UI? Like, what do you think? Studio glass? Studio glass? Okay, everyone is on studio glass. All right, some for frosted as well. Okay, studio glass it is. I'll tell it. I wish when I clicked, it would get the answer, you know. But hey, this is like, I'm telling you, I've never seen this side of Codex. It's for the first time. It's building this, UI on the fly to ask me these questions. Usually just chat discussions, which are brilliant, by the way. But it's like, this is what I like about Codex. There's new stuff to discover all the time. My recommendation: make temporary style lab route dev panel first. Makes sense. Okay, let's build it. Let's do that. We have chosen a UI, and at the same time, what I start discussing, folks, is the plan. And this is secret number one: build smaller prototypes, build smaller mini apps that do the important parts of what you're trying to build. And then if they become successful, then ask Codex to merge it and add it to the main big app that you're building towards. That way, if some part does not work, your main app is not getting stuck, and you can always explore multiple of these smaller ideas and tools together. And are you ready for my next secret framework? Because I think it's time to use it. How many of you heard of this word called MVP? And what does it stand for in case of techs and startups? What does MVP stand for? I use Anthropic skills as a plugin for in Codex. I have usually gotten minimum viable product. Absolutely right. Okay. Now you can watch. There are hours and hours of startup founders, builders, product managers talking about what an MVP is. And it's all philosophy, according to me. Here's the only practical framework that at least works in my opinion. It might not work for you, so test it and only then adopt it if it works for you. But do you folks want to know? This has been my go-to tool with AI, and the only tool that works for me and AI when we are working together. Do you want to know this tool, folks? Do you want to know the simple idea framework on actually zeroing an MVP? Yes? Okay. I call it my simple 1, 2, 3 framework. Okay. I read it as 1, 2, 3 framework. It's not 1, 2, 4. It's not 1, 2, 5. It's 1, 2, 3. What does it mean? You draw one big box, one big rectangle, and you draw two small rectangles. Okay. This is what you start with. You can have one main feature, core, heart, and soul feature. This is the app. Without this, the app does not make sense. And you are allowed maximum 2. Maximum. This is not minimum. You can decide not to have these 2, which is very difficult for most people. But max to max, you can add just only 2 other features. And you have to decide which are your big 1 and 2, 3. Okay. This is forced MVP. It will force you to think what you actually want to do. It will actually force you to do the negotiations. For example, let's do this exercise for something like ChatGPT. What do you think if I'm building ChatGPT? What is my one big main thing? What is the one thing that without it, ChatGPT is not ChatGPT? LLM chat. The LLM chat. I need to be able to chat with a model, right? So that is your, if I copy this over for ChatGPT, the main thing that is there, chat with AI. Okay. Without this, ChatGPT is not ChatGPT. So everyone is very clear what this is. But when you're working on SaaS, when you're working on a mobile app, when you're working on a consumer app, a B2B app, it's very difficult to make this decision. But that is the process. And trust me, Codex can actually help you reason with that as well. Though I encourage any human being to think about it without the AI. Now, in the other 2 boxes, okay, there is no, when I ask you, we will not agree on the other 2 features, and that's the point. No 2 builders will build it the same. Okay, that's the whole point. Now I can have, for example, chat history. I can, for example, have voice, recording, or live voice feature, or memory, or file upload. And for you, I want to know, for you folks, for you specifically, what will be the 2 other features you want in here, maximum 2. Without it, it is a deal breaker for you. Some people are saying image generation. Okay. Image generation, memory, I already wrote. Coding, deep research. I love deep research. I still use deep research. Okay. Video analyzing, Canvas. I use Canvas a lot as well. Yeah. I can see that smart home. Do you see? I want to know the non-negotiable, folks, not just anything. What are your non-negotiable thinking? Think, which is model switch essentially. Thinking, change the model. Okay. Can you see that? Change the model, agent mode. Agent mode is crazy. Real time. Okay. Can you see all of you have different requirements, different ideas? What about your non-negotiables are, right? That is exactly how you want to approach your MVP. This is the secret of building with AI. When you focus, the AI will focus. When you are clear, the AI will write clarity, move with clarity. And usually the problem is not AI's capabilities, it is our misunderstanding of what we think we are saying and what we are actually saying. These two ideas, okay, prototype, prototype, okay, keep prototyping, and the idea of minimum viable product. You do these two things, and that is the actual planning that you want to do. This is the actual plan work. Okay. This is your contribution to the planning. This is for your clarity and what is possible, what is not possible, what you understand and what you don't understand. All right. And then AI can plan further to write code on top of it. And from here, you can draw this out in a PRD, right? But to be very honest, this is your PRD. That is the whole point of MVP. Okay. This is going to be your PRD. It's a product requirement document. It is not an engineering requirement document. It is not a specification to model or write me code like that. That's engineering concern. That has nothing to do with product right here, right? Uh, Having said that, these boundaries between ERD, PRD, spec sheet, all are blurring because the same AI can help you write the PRD, can help you run marketing campaigns. Have you anyone tried to ask Codex to run Facebook ads for you? It's a lot of fun. You should give it a try. And it can also help you analyze the data. So these roles are more for human beings, and AI doesn't honestly care about it. You could ask to write PRD and ERD together, or you could ask it to write ERD and then measure PRD. AI doesn't care. Okay. AI can move it whichever way. It is usually limitations in our head, which are created and manifest that way. That is why I love building with AI because I'm at times I'm doing designers work, I'm doing product managers work, then I'm doing marketers work, then I'm doing engineers work, then I'm trying to deploy on Vercel or any other service. And that's the fun part about building. That's the fun. It's bringing fun to back to text. Grill me. Oh, grill me is amazing, and you can just do grill me in general as well. And I think surprisingly, I think 5.5 understands what you mean. And they are of course special. Meta ads are cool and a bit expensive. Yes, so keep it in a budget. And here I have, yes, we'll start treat class morphism control as temporary style lab, main app. Next question, pixel only, pixel and max file size. Or I recommend B for V1. It covers common painful parts. Yeah, let's go with B. I will go with B as well. And the interesting bit happens when I disagree with AI. Okay. I was telling you folks about this chat where I disagreed with it. And when I want to show you what do I do when I get stuck. I'm showing you from a personal project, which is machine learning project. I love using Codex for machine learning stuff. It's almost like having a wise coworker, a colleague who suddenly will say stuff and you're like, huh, I never thought about that. Okay. Let me see if I can show it to you. Okay. I think I was chatting up with AI about something. Why did you write code like that? Let me quickly show you. No, this is the plan. And yeah. So I was like, why did you yeah, there you go. So I was like, why did you write code like this? Okay. And it was like, why it became complex. I tried to make it one cell work. Sure, I give it. I tried to avoid embedding tokens in the notebook. This I did not think about. The token it's talking about is a password like token. It's an API key. and it did not want to put it in there because if it errors, it will put it in the logs and I'll end up pasting the token to codex, which did not want to do. I did not even think about this. I was just mad at it writing like complex code. I tried to support clone if missing plus, pull if present. I didn't ask for it, but the thought is not bad. I tried to make notebook AST and rough, and the moment it said that, I'm like, oh, I have a rule in my project that all Python must pass rough test. Okay, rough is a linter for Python, and which is a great thing in general, but not for notebooks written for Google Colab, which will run on Google Colab. There's a service for like where you can get GPUs, etc. And it's pretty hard to write code that will make Rust happy, rough happy on Python. And I'm like, just scrap code, rewrite it, etc. But for a moment, I was like, let me just ask. And the moment I asked, I was like, you're right. If I was in your place, I would probably just give up. But you actually wrote the code. And so I actually started changing the instructions I gave it. If you're stuck with AI, especially with Codex, right? You're feeling stuck and it's not able to get this stuff done, just turn it around and genuinely ask, hey, I want you to let me know what is going on and why are we stuck and why do you think it's happening and why do you think, like, ask the why and what it was it thinking. And the moment you do that, you will realize that your view of what you are asking the AI to do and the AI's view of what you are asking it to do are not matched ever. Like every single time I've been stuck, that has been the case. And then I'm able to like reason through and talk to it and get it in place where it's running. And in the end, we had results. We had actual real results of this training run. And those of you are interested and could make sense of what is there, we reached PSNR of 27. I think it's trying to build a visual tokenizer, and I think the experiment was quite a success. And the only model I will trust to write that machine learning code, honestly, is Codex. I don't let any other model touch that code because I'm like, I need to know that what I told you, what is in there, and what you're telling me is all the same thing. And the only, since GPT-5, the only model that can be trusted with that, in my opinion, is Codex. So, like, thanks for existence of Codex, because I don't know what I'll be doing without it, because I've tried with other models without taking names. They are good, sure, but they lie. Yeah, that's my problem. Like, at least don't lie to me. Like, I want to know like what is going in there, right? Sometimes Codex rejects your prompt saying your prompt is not secured. The moment it says that, you want to know, you want to ask what is not secure. I have learned so much about security and security concerns just chatting and asking questions about whenever I think AI's replies are strange. Right, I'm just like, what do you mean? And usually there's something to learn in there. So I am having a dual role here, which is like super fun in my opinion. Let's go back to the project we were working on. Alternatives, step by step, recommended. You know what? Just I think at this point I'm not able to like think it through. How about you just build me an MVP, especially on UI? Give me some controls, like give a setting button which can give me some dials, some things to move things around, and let like set it up nicely. And I want you to use Tailwind. So and yeah, like let's be very clear about that. And I want to then settle on both the decisions. When I see, I think I'll be better able to decide. Right now, you're asking me questions, but I don't have very clear idea of what you're talking about. Like, I don't know what that translates to in UI. So maybe present me all the options as a prototype. How about that? Now, if I was typing it, folks, okay, I would not write the fact that I am not clear what I want. But when I'm speaking, I'll blabber. And at times I have recorded longer notes with, Whisperflow, Super Whisper, and other apps, because I believe, at least in ChatGPT, is limited to 10 minutes of recording. I discovered that the hard way. One day I'm just yapping and yapping and yapping and yapping. It's been, I think, 30 minutes I'm yapping about an app. And I realized ChatGPT stopped recording 10 minutes ago. That day I learned my lesson, like, so I for longer conversation, I'm But Opus 4.7 is also insane. Yes, Opus 4.7 is good. Gemini 3.1 Pro has its prowess. But my issue is reliability, right? Just an example, Gemini is either a genius or I'm like, what the hell? Are you the same model? Did they do something to you? Right? Codex is reliable partner, I feel. It's much more reliable for me at least. Right? Yeah, so the reliability is a factor. And usually what happens is if I'm using other models, which I do often, I usually do bring in Codex to clean the code up. Because talking is one thing, and actually writing decent code, which when I look at it, I will not be horrified. Uh, yeah, so Codex is usually involved in every project, even if there's another model, because, and I'm not just saying it for the sake of it, I genuinely bring in Codex to clean up shit. And if you are a software engineer, if you are from tech background, and you are tired of it writing code, which is like, and there are certain models which will leave a lot of files in clutter. You know which one I'm talking about. They'll create a random markdown file. They'll create random markdown files inside the folder. They'll create a new folder when there's not another folder. You know which model I'm talking about. I bring in Codex and I'm like, can you please clean up the clutter? And it will just do it. It will just do it. All right. I am not taking any names. You know which one I'm talking about. People know. Okay. What about Gamma? Gamma 4 is genius. Quick question that I'm currently 16 with an embedded system background. Crazy. So which is beneficial to learn in 2026? Learn a specific language like Python or just learn to code and ship app using AI? Learn to code, Tanmay, always will be valuable, even if AI can write the code, because anyone who codes can move faster with AI. Okay. Even because I think we are done with the era where software engineers will write code without AI. Some level of AI is involved, even if it is just AI copilot like autocomplete. Some AI is always involved. Very rare, like unless software engineer for some reason decides not to involve it. And if that's the world, the incentive to learn to code is less. I understand that. But if you do, the reward will be disproportional. And that has always been the case in the world. The incentive to do the hard thing is always been less, but then the reward for doing the hard thing has always been great, right? If you take up machine learning, for example, if I see every single sample of data, I have like 1 million photos, right, going through. I can't possibly sit through 1 million photos, but then there are people like Andrej and Ilya and people who back in the day, like they went through their stories, they went through every single sample of their data set, right? And they won. Like it shows up when you are that dedicated. So do the hard thing. And I think if you are in embedded system, I'm guessing you have picked it up by your interest, right? And you're writing code with interest. So just fuel that interest out of no reason, but for which works when you're younger, just passion and like, I will win the world. And if you're old and aging, then you can use spite. Spite also works. All right. And just, it like going deep into code, I think is still very, very rewarding emotionally, at least for me, because I find Zen in code. I still want to look at some code and handwrite some code because there is something Zen about it, which is extremely hard to explain. And then, I learned to code first, then I became a designer, then I became a PM. So my relationship with code is older. And till date, code is a lot of reason what calls me to tech. And I still, I want to code just because I can. And not just and want to code with AI just because I can, and the fun of building and it's back, So, and there are certain apps I am able to build just because I am like, so deep into what do you call it? What is going on kind sort of way. So in fact, after AI came up, I've learned more about more systems and than I did before, because finally I don't have to spend so much time bug fixing. And I know what code should be written. I will just blabber it to AI. Though more and more I have started to leave the project, the details, what code has to be written, all of that stuff to AI. As we speak, by the way, AI is writing code, and you can see that it's the server is now running here, I believe, but I don't see updates. I think it is updating that. We'll see an update right here. So more and more, I'm just relying on AI because I realize the way I organize folders And files, it's not the same way AI organizes code and folders and files. So more and more, I'm leaving the project, and this is a phase number two. When you build the MVP and you're building a serious app, right? You're now starting to go from a very small MVP to trying to build, meaningful MVP. So you will add login details, you will add some security measures, etc. Your files and stuff will become, more complicated. There is a couple of rules that still helps with AI, and I want to let you know. One simple rule I want to highly encourage: no file above 250 lines of code. Okay. The thing is, when AI is writing code, those of you not familiar, it will write a bunch of lines. I can show that to you, right? Let's pull that out. Um, these are the files. And for example, it has written this index.html, right? And it's a file. And without getting into too much code, this is 148 lines of code, right? 148, you can see right here. I have noticed that the moment it crosses to 300 mark, most models struggle to even make basic edits. And it's true for all models across the board. Plus, they struggle to fully picture what is going on. So I usually add this one rule: no file above 250 lines of code. If you have written it, if you discover there's a file above 250 lines of code, in the next message, let me know in your next message and offer to refactor it when it's like time. And if that happens, first thing AI should do is inform me that this has happened. Okay. And second thing I wanted to do is refactor it. So it is not 250 lines of code. Okay. Another way to say refactor is rewrite it as per the rule. All right. This one small trick has prevented so much pain. Okay. And trust me, humans don't like code like this. Humans do not write code like this. I have files with my friends and projects. We have 3,000 lines of code in a file. And we on purpose keep it that way because for a human being, it needs to be in a single context. No AI has been able to make even a basic edit as like add a comment at line number so and so, like been there. They mess that up royally. AI writes code, writes file, organizes its projects differently than a human being. You have to decide where do you draw the line. For an MVP, I'm like, I do not care unless I'm building a tech product, etc. Right? What about HTML? HTML can be an exception, but because I'm using React, I can enforce that rule, and I do enforce that rule, and I'm happy for it, honestly. Right? It forces me again and again to reorganize my components, rethink my strategy. And especially like with React and Next.js coming in HTML, it is completely possible. There are, I think, two exceptions that are there. One is when you're writing IPython notebooks for Google ML work, etc., IPy notebooks. And the second exception sometimes comes in pure HTML, workflows. There, yes, but even there, I will pick up some templating language. There is handlebars. There is so many options that you can do, which will allow you to break down into smaller parts. Even for a static site generator, there is Astro. If you're not tried out, try Astro. Right, they will give you leverage of being able to just break this down. And every single time I have put this rule in place, the performance is so much better. I get stuck less. Right. Now that like just mimicking a certain person. Okay, I think it should be big, beautiful, meaningful MVP. In Rust, usually when I ever use parameter or method, it keeps adding a line for each parameter, and I refactor that. I get a lot of line of code. Tarun, I'm not familiar enough with Rust to be able to address that. However, if you are into code, another trick I would like to mention. How many of you know this idea of type checking, type hints? Anyone? Okay. Anyone? I mean, code people will know. Okay, here's a trick. For other people, it might be a trick, but it has saved me more pain. Okay, you want to use something known as Zord. Okay, think of schemas. Schemas is basically an agreement on this is the shape of a data. Schema is basically shape of data. Okay. Usually what is happening is AI is just like writing different shapes of data. Okay. If you want to get a little bit technical, if you're okay with it, especially when something is sensitive, it's not working, it's breaking again and again, try to talk to AI about the shape of data. If you're building in Python, you can use something called as Pydantic. And if you don't know what code it is writing, most likely it is writing TypeScript, okay, or JavaScript. You can ask your AI what language it's using, or just tell it, give the code that I'm like, mention what I was saying, and it will tell you what how it should apply. You can use Zord, okay. I mean, use TypeScript, please. Ask your AI, ask your nearest AI for the TypeScript, okay. Of conditions apply, terms and services apply. Please read the offer document carefully before investing. But this simple idea, at least let's Codex today agree or disagree with Codex yesterday, okay. And me and Codex usually are talking in schemas. And that is how we have discovered things work for us. Having said that, let's go back to our browser and see what it has built. Go to this app, okay. All right, we have an app. And I want to first check out the UI. And let's see, like, oh, nice. But why is it only increasing? All right. Something is up. Yeah, it just keeps going on and on. That is one issue that I can tell it to fix. Oh, it gives us all three options. Now we can look at it. Do you want crystal light, frosted paper, or studio glass, folks? Which one is your favorite? Do you see the rounding also changes? Right? Which one do we like? This is frosted paper. I can put this to side or float. I don't know what that option is changing. Oh, okay. So this is the blur setting. Can you see the blur? I think for legibility, this is better. I want a little more opacity, but that makes the white more white. Okay. Yeah. And then we can change the border. Oh, I like that. I think somewhere there. Shadows. Yeah. Teal light. Okay, that's the teal light in the background. Can you see in this area? That's the teal light we have. And I think somewhere there I will leave it. The pink light, I think that's on that direction. The density. Oh, do you see that density? Oh, I like that. All right. And there we have. This is my favorite way of building UI with any model, especially with Codex. I used people like instead of getting tied to some app, etc. I'm like, give me a UI with these options and give me control so I can adjust things. Now, what I can tell it, I can read out the values from the and tell it, hey, this is the values I want. Set it to this, set it to that. I can ask it to change it. I can ask it to do something else. All those options are available. All right. And I can also ask it, hey, I don't like any of this. Give me something completely new. All right. And that is how I get those results. And I'm like, I'm not a genius who will know exactly what I want. Right. I will play around and I'll figure it out. And we will figure it out together. So that is the way I go about these now. Right. And I hope this one trick helps you and in building sort of like the UI that you want. This is my way of getting the UI that I want. The kind of UIs that are possible with AI is crazy. Especially if you combine multiple models, it can get even crazier. But I always use this trick where I'm like, give me the controls and then read from the values that are there. This is exactly how I want it. This is what I want you to set. All right. If you found this useful, drop a boom in the chat. If you found this to be like exciting, because this is my favorite way. I'm literally building this in front of you. I have not pre-planned. There is no rules, etc. here. I'm showing this to you live that because I told you I'm that confident in Codex's ability to deliver what I'm asking for because I use it so much, right? That I know it, like where it's gonna break. Like I can, I know it well enough that it's gonna get this kind of things. Really amazing. Which language to learn from? Which language to learn from Tanmay? Um, which language to learn? Pick any language, honestly. And if you're writing code with AI, does it matter which language it's writing? More and more, I'm realizing like you pick the language as long as it's not C++, right? Because I don't want C++ has just way too much power. Um, Even Rust does, but and C++ has powers way beyond my control. Okay, so that's a beast I wouldn't touch. Like if you want to, that's up to you. But the point is, if I am not writing the code and I'm not even looking at the code, how do I care in which language is it writing? I have some principles. I want them to be followed. And then I let the AI pick whatever it picks. And usually it will pick TypeScript. And it's a good thing, which means all of these options are available to you. Okay. TypeScript is flavor of JavaScript. People will not agree with that definition. That's fine. I'm trying to talk to non-coders as well. And it allows you to do all of this. All of this. You can build a desktop app, a mobile app, native. No, native you can. React Native. We have if you're trying to build a native app, I don't know why you care about so much about it being native, but maybe you want performance, maybe you want GPUs. You can explore something called as Expo, which is essentially built on top of React Native. Okay, and you can also ask it to write what is Flutter, I think, but Flutter does not compile to native, and Flutter apps don't feel the same, especially after glass morphism and iOS 26, whichever version we are on. But Expo is fantastic. I don't know if you've seen Expo. Let me show you Expo quickly. All right, build and test faster. Oh, that's the Expo. I am on the wrong Expo. What kind of ad is this? Oh, there you go. You can build that kind of app. They have better homepage. Let's go to homepage. All right, you can build these kind of apps. And Codex is great at writing this code. All right. And our designers first started building apps actually using Expo. And he would be sitting at his home designing. And Expo has a setup where I can download their app and use it. The code is running on their machine. Like if please talk to your IT services department and legal department if you're working on office things. But it is super easy to get this stuff set up. Even if you want to write native Swift apps, ask Codex to set it up for you, and you can do a lot of stuff. But Expo is so much fun to build with. It is less banging my head against the wall. If you want to build mobile apps, I highly recommend Expo with Codex. It is fantastic experience. In fact, if I remember correctly, they have a feature specifically addressing what do you call it? Let's look at it. There is something they had for Expo. There you go. They have a plugin for Expo. Switch it on and have fun. Like it is absolutely crazy what it is capable of building and how fast it will build. I'm usually like thoroughly impressed. How many of you know about automations and security? Oh, I want to show you another side of the Codex. Any of you who have $20 subscription, the $20 plan on OpenAI, did you know the Codex app is on web as well? Have you seen this? Have you seen this? If you've not seen this, folks, I am so happy that I get to introduce you to this one. This is my favorite feature of About Codex. I mean, I love the app, don't get me wrong, but this is some serious stuff, okay? This is the web interface for Codex, okay? Now, why do I care? Because this is the older UI. Yes, I see some people recognizing. First, we can use Codex only on web, correct, Yash? First, it was available here. They have the recording feature, my favorite. They have the plan feature, okay? You can actually switch the branch. You can get 4 versions. It's a little expensive now, but so please be careful if you're running out of credits. But same prompt, 4 codecs run in parallel. You take a look at this and you can combine, pick one winner, etc. Super underrated for UI. And the best part is it runs in the cloud. It runs in the cloud. Okay. all runs in the cloud, and it will pick up code from your GitHub. It will do its planning, etc. over there, right? And the best part is, if you've not seen it, have you tried the Codex feature on ChatGPT app? And do you know about the new Codex feature on ChatGPT app? Do you know about it? How many of you know about it? Yes, no? Yes? Okay. No? Okay. Let me tell you one thing. There are two ways you can use Codex Mobile. Okay. And this is my favorite way to code when I'm traveling. So Codex is usually on my system. Okay. My system it's running. But that means I have to carry my laptop around, like, keep it open with Tmarks and God knows what other, like, shenanigans I have to do. Or I can say, hey, Codex, take my code, take it into the cloud. You spin up your own computer and, do the thing over there and then raise a Git PR. A PR is like, hey, I'm requesting to make changes to this code. Okay. And code, then another Codex can come in and review those changes as well. It's a lot of fun. I use multiple AIs to review. So it can then contribute to the same thing using Git and GitHub. Sign up for a free account on Git and GitHub. Ask, Git for Codex for a tour, and it will give you one, and you can put on GitHub. And then what you can do is they have the mobile app, which can now do, this is on my laptop. Okay. My favorite part is now Codex mobile app, which is part of the ChatGPT app. It can do both. Okay. Not only can it do the cloud thing, which is the feature they have had since, I don't know, 100 years. Okay. In AI time, that's 100 years. It can also run it on your laptop. So you can leave your laptop where it is, go take a walk. While walking, think thoughts of greatness, blabber it to AI, and it will take that code and run that prompt and code on your laptop. It'll keep it awake, prevent it from sleeping, all of that jazz. It's the best feature I've ever had. I use this one when I'm traveling. Okay. When I'm traveling somewhere, my friends know it. Okay. I will be asleep. I sleep on, especially on a road trip. I'm just sleeping. Okay. 8 hour road trip. I've slept 9 hours out of 8. Okay. How you figure the math. And I will only wake up to drink water, and when we are taking a break, so I can access the loo. And for third thing, I will look at the prompt and I'm like, can you do this as well? This as well, blah, 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 and pass out again, and I'm out. Okay. And Codex is so good at it, it'll stop recording after 10 minutes, send the prompt and start working. And by the time I reach at the end of travels, I have 5 more features done, folks. I have 5 more features done. That's my favorite way to do. And when I am at home or I'm nearby or at work, right? When I'm just near my, places, like especially home at work, I use this one because once I'm done, I go back to my laptop and it is up and running and working for me. All right. It is absolutely the most fun thing to use. You have to set it up once. You have to do some QR codes, scanning, etc. It will guide you. The app will guide you through. These are literally, I don't think people talk about this enough. And I don't think people even know about this feature. But OpenAI has been trying to unify this for the longest time. Okay, now you see web interfaces popping up on other people. But OpenAI was attempting this back, like, I remember Codex first, they put, like, it's been more than 1.5, and that's like decades in AI years. You folks know what I'm talking about. GPT 5.2 came out like last year. It's bizarre, like, how time moves in AI world. And I think they're the first one to get this experience so seriously right. And it has taken them a long time. Okay. It's not been like I have used the buggy versions, etc. But they have gotten so good at this. I am impressed by this. This is my favorite feature to set things up. And the last piece I want to show you is, this is my favorite feature, which I told you I'm using a lot, is bug fixing. Okay. And screaming at AI. Okay. Shouting, questioning, crisis. Okay. I don't know about you. Every single time I see a bug, I'm like, why? Why me? Out of all people, the bug has chosen me. Okay. Like all sorts of thing is happens. Um, I am OpenAI Paglo. No, I have enough criticism for OpenAI, very honestly. Okay. But credit where it's due, because it is not easy to become my go-to, model. I have very high bars and my team knows it. And for the longest time, I wasn't a big fan of Codex, but that has changed. And that is why I'm excited to talk about it, because it changed my opinion. I still remember, and I'm still, for example, I'm mad at OpenAI for taking away GPT-5 from me. GPT-5, not 5.1, not 5.2, not 5.3, not 5.5. GPT 5.0 was so good at UI, was so brilliant at UI. It taught me certain things about design, and I've been a designer for 15 plus years. Okay, I can tell you exactly what it taught me. It taught me certain things about Canvas, what it could do. I did not know. It taught me about OKLCH color scheme. I did not know. It became a teacher. Okay. And my favorite part about GPT-5 will remain that it did not want to talk. And we were so good together. I did not want to talk. GPT-5 did not want to talk. So we exchanged very few words. And those words were meaningful words. And then now it writes better code, but it doesn't do the teaching. Okay. I know they will crack it, they will figure it out, because they've had the learn mode. They were the first one to build the learn mode, which I loved using because I love building this thing tools. I see the improvement in 5.5. We are closer to this. So they're gaining back on this ground. But that genius that GPT 5.5 was, GPT-5 was, I will always miss it. However, having said that, the quality of code, the ability to solve complex problem consistently from GPT-5 to 5.5, there has been improvement. So that's a trade-off. It's not an easy trade-off. But boy, I remember my jaw dropped because I gave it some screenshots from Dribble, famous website, famously known for building UIs which are not possible. And it built it. It did the job. It warned me about what will fail. It warned me what when GPU will be hammered. And I actually learned for the first time. And now I see the hints of that, teacher coming back in GPT 5.5. Hints of that are definitely back. That is why it has become my go-to model. And you saw that teaching thing is back because told me that I have rough rule. And that is why it had to write Python like that. And it's trying not to create security issues, things I didn't even think about could be an issues. So that angle of that I enjoyed about GPT-5 is coming back. And that is why I am here for it, right? And don't take my word for it. Tomorrow, if another model jumps and does better, I will switch my allegiance like that. I'm not kidding. Ask my team. One day I wake up, I'm like, oh, you using that model? Who uses that model anymore? Next day, I'm like, oh, you're still using that model. Like, and now it's the third model. Okay. So I switch very, very fast. All right. And my team knows it. And right now, this is my favorite. And I genuinely love certain things about the setup that OpenAI has been building for the longest time. And I've seen the journey. That's why I'm trying to show it to you folks, because I've been deep in this ecosystem for a while and I test all of them out. And then some things are remarkable. And here's another one. All right. For example, I, let's say, want to completely change this UI and I want to go with a different UI, right? And I wanted to maybe use my computer, maybe look at the UI of like a certain app, etc. I can switch on computer use and I can ask it to like debug, on a certain, platform, etc. Or I can even ask it, this is the most fun thing, I can even ask it to set up a repo so it works, on cloud. And one more feature, I think this is a pro feature, so I will not to spend too long on it. But in case you have pro access from your company, look at the security tab right here. Okay, you can go to security and you can actually ask it to do, I think it's a new feature. You can ask it to do security scans. And I love the reports that it brings out. If you're working on an enterprise plan, you have concerns, you have, like a lot of AI is writing code and you're very uneasy about like what is going on, give this security scan features a try. I have been impressed. I've been impressed by the reports that it produces. Very few people have access to, I think it's pro only feature. So I will again like spend not too much time over it. But these reports are actually very thorough, thought through, and I still feel like a human being should look at production system which are like have which store customer data. Software engineers are not going anywhere anytime soon. But this one also is complementary, especially if you build if you're an entrepreneur, hustling to build an app, etc. This is an underrated feature. Last, I want to show you, the what do you call it? This feature of it being able to use Chrome. I'm going to ask it to do something super odd, which it doesn't need to do this, just to demonstrate how it can do it. Can you open expo dot dev on Google Chrome or using computer use? I want you to. Why am I typing it out? Who does that anymore, right? Can you open expo.dev using computer use and Chrome tool and do it like specifically using those two tools? I know you can access a URL outside of it, but I want to demonstrate to our audience, computer use feature. So please open it using that. And I want you to go through the docs, etc. And can we do the same design that we have here, but using Expo? Is it possible? I want you to let me know about that. And the reason I'm asking about this is because I think these apps exist on websites to resize, downsize photos for government work, etc. But the issue is, I am on phone most of the time. I don't like, and there the ability to get exactly like within 200 KB, etc. is difficult. So I want it to be a mobile app. I want it to function properly on a mobile app and as a website as well. And I don't want to keep writing code again and again. So can you check out the documentation and tell me if it's viable for us to build this using Expo? And yeah, just take a look and please use computer use for that. Let's build GPT-6 using 5.5. I'm sure OpenAI team does that. No blowing smoke where it does not belong. Okay. Yeah, makes sense. Man enough, now this feels like how to use ChatGPT codes. This is all just to show a startup and get Codex free price. They are just promoting Codex, nothing else. Sure. I mean, you can say that. It's a Codex hackathon after all. And but I am showing you frameworks and tools that I actually genuinely use. Are you serious? Did you lose my? Oh, thank God there's a retry button. Thank God there's a retry button. You saw it losing my audio right now. So much I spoke. Because I don't use this feature on other AI apps because they lose my audio and I lose my shit because I'm like, I was speaking for good 5 minutes. You can't lose that audio. Will we get the recordings? I don't know. Om can let us know. There is a plugin to in Codex is Codex Security, correct? They have skills as well and Codex Security, etc. as well. This is a feature which I like because I can keep in, like I get to explain. By the way, it has access to a browser right here. So it does not technically use your Chrome. But at times you are logged in your Chrome and you don't want to log in here for obvious reasons. And that is when you can use Chrome, use. And then there is computer use, which is beyond Chrome. All right. And for Chrome, there's a plugin. You can install Chrome plugin and then it gives it access. And Expo UI skill confirm a key caveat. So it's gone to the skill, a skill I already have Expo installed. So Tailwind CSS is not available. All right. And there's native wind things deliberately, official Expo docs mention. List Mac apps, all right. It's trying to list all the Mac apps. Whisper Flow is damn good for narration. Yes, I use Super Whisper. Whoever wins the session will them a lot, okay? Chrome is running. I don't know what you will do with the recording of the session because these things will change tomorrow. Tomorrow, new model will drop and my entire workflow will change. I will test the model, usually like spend 2-3 nights testing it. And then I know where this fits. And all of this will change tomorrow, right? So I don't want you to have outdated information. With AI, can you see that? Allow Codex to use Google Chrome? Sure, go for it. I do not press always allow. That's not happening, not under my watch, not on my machine. Okay. App state first. All right. It's looking at Google Chrome, but where is it looking at Google Chrome? Which Google Chrome is it looking at? You can't see the icon right now, but that there's an icon and a cursor tracker that comes up. Can I see it here? I don't know if I see the cursor here. I think this is that is controlling. Yeah, it's going to the docs right now. My hands are here. This is all. Oh, there is a cursor. Do you see this cursor? This is This is GPT's cursor. Let's watch it. Like it's kind of fun to watch it use the website. Though I'm telling you, this is completely wasteful. For reading websites, it does not need any of this. It can access the export docs much more easily via plugin, etc. That's why those are built. But I'm specifically demonstrating to you the computer use abilities, because when you're building web apps, when you're building mobile apps, you want it to do the drag, the thing, and actually load up the app. You don't like I have stopped going to the apps and testing them myself. It's ChatGPT doing it for me and testing the apps, etc. And I use computer use feature for that. It can spin up your app. It can go to like your logger and get the logs from there. It can do all of those setups. If you are a tech nerd, etc., and you can write code, I highly recommend trying to set up tmux. Oh, tmux is next level, insane, because using tmux I can allow codex to talk to other AI. So Codex can talk to Claude, can talk to Gemini, can talk to each other, and open code and stuff. And they can keep an eye on the logs and a whole bunch of things. Like if I am the person who introduces you to Tmux, I would be proud. All right. Oh, by the way, it's still using the computer use. Okay. We just decided to scroll down. How can you zoom up a bit? I can, but it will not zoom the tiny cursor. What about token usage when an LLM communicate with another LLM? Yeah, that does become an issue. But for security review and all, like I usually do that. Like I let them gang up and do red teaming on certain things, and that usually is worth it. Things you teach are for the real world practical skill. I appreciate you and team effort, but my question is about hackathon like project presentation and all. Yes, I think Om can take care. Om, let me know if you want to take it up, because I'm almost at the tail end, and you can answer. You will get answers to all the questions around hackathon. What do you think about using Codex plugin in Claude Code, Claude's plan, Codex code, and debugs? I think, what do I think about it? I don't particularly, I'm not like tied to Claude Code's hardness. Back in the day, it used to be like superior. Now it is not. It's, I mean, it's not bad. It's just like everything else. So actually, I use Codex, and in Codex, I use Codex in T3 code. If you're not seeing T3 code, this is T3 code. They have some features missing, but I find the experience much more pleasant. Let me fire up T3 code. I use Codex via T3 code, and at times I have tried with open code as well. Your Codex subscription, by the way, will work in T3 code, will work in open code. That is true for Copilot. That is true for I think almost everyone except Claude. Claude you have to use in Claude code only. Where is T3 code and why isn't it loading up? Don't tell me one time I'm trying to give a demo, it's not there. Don't die on me, T3 code. Come on. We had this conversation. You can't do this. Not on a live demo day. Come on, T3 code. If you've not tried open code, you may enjoy it better, especially if you're coming from tech, etc. background. Open code it has its perks. All right. So for example, I can just go here and do open code, and I can Codex subscription and use multiple coding plans here. For example, I have GLM 5.1 coding plan as well. I have a bunch of coding plans. I keep testing all of their models and keep trying them for different things. And you can use your Codex subscription here. And why is T3 code just not there? Oh, there is T3 code. There you go. I'm not updated in a while. I use a lot of Codex here as well. And there you go. Codex is set up right here. Claude code you can't use. Codex you can absolutely use. I think they have enabled cursor as well, and open code I started using via this setup. This is my go-to app. I use this app to access it a lot. However, it does not have all the Codex features. So for certain projects, I switch back to Codex app, but otherwise, this is my go-to app for using multiple things. Please do not use Claude outside Claude code in case you have subscription. Anthropic doesn't like when you use them outside of it. But every other place will allow you to use it. So cursor is fine. I think cursor they will allow you to use right here. The reason I like this is all my conversation in one place, and I don't have to keep switching apps. Otherwise, it becomes a little bonkers when you're using multiple apps. They have all the stuff that you would want to use. So do try T3 code. I think there are a few other ones. There is, for example, I think it's called Conductor. Conductor was the first one with this kind of setup. So I've used Conductor in the past as well, which is fun. But these are just tools, though they matter, because in the end, you and me will spend a ton of time in these tools now, right? And ID is not where I'm spending a ton of time. And just FYI, I think it's done browsing the thing, and I think we would have a reply. These are the replies that I have. And last important tip that I want to give you, I showed you the skills, I showed you the plugins, the web interface, the cloud interface, T3 code. I showed you how I built. I've shown you UI. Uh, Codex doesn't need like introduction, like able to write logic. It's fairly good at it. The only last part I want to emphasize, and it's so important. How many of you will ask it to do something? Model will write, and doesn't matter which model. Model will write a huge answer, and you don't read it. And you won't read it. How many of you? Be honest. Put a yes in the chat. Okay. Those of you are doing that. Okay. You are leaving so much money on the table. You will go read the code. You'll go read everything else, but you won't read the model's reply. If you don't like the reply, it's long. Okay. Can you tell me in short, please? My attention span is fried today. Just ask, and it will give it to you the same thing in short. But before you read the code, before you try the app, my only tip, which is the hardest tip to follow, I know, read what it wrote. There is so much in there. There is so much in, at times I've seen my colleagues, okay? There are all caps screaming, build it the way I am asking. What is wrong with you? I have done this. And they have not read 5 messages where it's telling them, hey, I do not have permission to do this. Are you sure you want to take that route? It's asking important questions that have to be answered. And people are like, it didn't work for me. But did you read? Okay. Expo is a good fit. One code base can pick up photos. Okay. I can even ask it to narrow it down. Speak like caveman. Okay. To word max. You want even easier version, right? Ask it to speak like caveman. You'll get what it's trying to say in the expo good. There you go. Does it work? Will you now read it? Will you now read it? Did we get it? Like expo good? We got our answers. But please, if there is one tip I can give you, okay, with any AI, if you want to leverage it, this is the most underrated tip, and this is where people who build with AI win. Read what it says before anything else. If you think, oh, it's blabbering again, in your project, change the settings and ask it to speak like a, say useless words. Okay. If you still have less attention span, caveman. Okay. And we're back to building and having fun again. All right. But people will not read it. People will not read their own prompt because we are impatient. And I'm like, if you just read this 5 messages ago, you would not burn so many credits. You would not. And the thing is, folks, I want you to remember, you and me are human beings. Okay. When we enrage, when we are raging, when we are like, this AI does not understand my greatness, the only person who is feeling the pain is you. AI, you can scream at it. The AI doesn't feel the pain. It doesn't feel no shame. And it didn't even know it happened because you know what happened? Somebody spinned up codex and codex did not even remember who you are. So only people who suffer is you and me. Please suffer less. Okay. Life is enough suffering. We don't need to bring suffering upon ourselves by paying for AI to bring suffering. And simple way to suffering is read what the AI is saying when it's talking to you. And if you don't like its behavior, go change your instructions. Go to the settings. Go to the your actual settings. Go to the personalization. And right here, use less words. Speak like caveman. My attention span is low. Okay. And one important trick I can give you, if you ever feel instructions contradict, flag it with codex confused. Okay. Simple two things. And this one will save you so much time. The amount of time I am giving conflicting instruction, codex will be like, conflict. I am not sure. I'm like, oh, yeah, that makes sense. I told you not never to touch it, and now I'm telling you to touch it. Like, I have to be like a little crazy. All right. I do not like my AI to be friendly. I don't know if you figured it out. I want my AI to feel like an AI. I don't want to feel a human. You get your to decide your own personal flavor. So I usually keep it around pragmatic, etc. I do not want form AI. My chat GPT and my codex will never use an emoji. They are forbidden to do that. So please use customization and make the most out of what you're trying to get. And my every single time I'm frustrated while building AI, I usually have now started to ask the very AI who did the wrong thing to go like, why? Help me understand what's wrong, help me understand where we did not agree, because every single time that has happened is because me, AI, and the code are not on the same page. I am not driving the code, I'm driving the AI. So there's something wrong happening and I want to know why. And every single time I've asked why, my entire system has improved. Okay, my entire system has improved. So the last step I will give you is, what people will do is they will write a prompt. Okay, then they will check it works or doesn't work. Okay, you will check it, and then you will be like, oh, I checked it and it doesn't work, and now I will give it another prompt, and then I will check it again, and then I'll give it another prompt, and I will check it again. How many of you do this? And I'll give it another prompt, and I'll check it again, and get frustrated and scream at it. Instead of doing this, what I started doing is I check, and then I ask further questions. Okay, I've changed my game, and what I do is I will check, and then I will ask questions, and have discussions about what went wrong. And then I go back and start my prompt again afresh, delete everything and start afresh with a new system. Okay, i call is I call this change the system, change the basics, change the fundamental. Make sure, if AI made a mistake, how can I change my starting prompt so it doesn't land in this soup to begin with? This simple trick has been game changer for me. There are apps that I've built that I have no business knowing how to build. I have built them and they work fantastic and they work great. I can show you one quick example before we close. So, you can see it. This is an app that I built, on my machine with multiple AIs. Multiple AIs were used for this. It's still not over the finish line. It's an Electron app. It does meeting recording, sort of my version of Granola clone, if you will. And I wanted to take on Electron, especially as a challenge, and and it did it. It will actually record, and I think the UI and performance is not bad. Like, there are things to improve in this entire piece, but I'm still happy with what I have going on here. And let's see if it records and it is able to, retract your Slack secrets. Oh my God, have I leaked my secrets? Yes, I've opened the environment file. Oh no, what have I done? Thanks for letting me know. Thanks for letting me know, because great. That couldn't have been the best. Let me revoke it right away. But what I'm doing, is um, recording my audio, and I will stop recording it right now and see if that works or not. This is completely AI built app. I have not built this app myself. Okay. I have not written a single line of code. And this is like where we are at. And I use multiple of these apps every day, by the way. And why I built it is just because I wanted to see, right? Just want to see like how it feels and how it works to build this app. And I think it's been really phenomenal, especially because there you go. Okay, this is what I was talking about. I have the audio recording as well. It's like, I don't know, 290 KBs or something. And this app was completely, this is just one of the apps I have built. This is just one of the apps that I have worked on with AI. I have built so much software in last 1.5 and 2 years that I can't tell you about it, mostly for fun, mostly for just having just seeing if I can build it or not, just for myself, just for my team, and we build throwaway apps, just do one or two, three things. So for the first time, prototypes are possible. Build a lot of prototypes, don't get married to one thing. And these are my top tips that I could share with you. I've been building with AI for longer than it was cool. I started with pasting ChatGPT 3.5 question answer and code from here to there. And since then, it's come a long way. These are my favorite tips to build with AI. I hope these were helpful for you. And let me know. I'm so sorry. I like way over short time, but I hope this was helpful. Meanwhile, I should urgently retract the environment variables.
Yeah.
I mean, it was a matter of time. It would have happened one day anyway, right? Who am I?
Got it. Folks, how was this? How was this? How was this? In the chat, folks, did you enjoy? Did you understand what actually scope of MVP is? How do you think about it? What are the kind of things that you could leverage? Yeah. Perfect. See good reactions coming in. Bro
Bro
looks
looks
like
like
some
Sundar
food.
Pichai. My God. I don't know if that's a compliment or not, but
Okay. Okay. Take it. For some other day, I'll give you a chance. Perfect, perfect. Thank you so much, Siddharth, for doing this. This is not fair. I'm supposed to do this session before building the MVP. Folks, that is why you have 3 more days to sort of submit the final product, right? This is stage one for a reason. So yeah. So much useful advice. Love the little tricks. Why is your LinkedIn account so new? Who's Pratham? Is it me, Siddharth? Which one? Or you might be seeing some
oh,
other.
I think you're talking about your LinkedIn
Yeah, no, someone faked it. So that is why my name on LinkedIn is
account.
different. I've completed on things. Okay, perfect. 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 Folks, do you have any questions? Any quick questions for Siddharth? Anything about MVP? I'll take the logistical questions in a bit, 5 minutes. But if till the time we have Siddharth for next 10 minutes, any questions? Can we LinkedIn accounts of Siddharth? Siddharth, do you want to give the Twitter? Let me find it.
I'm more active on x.com because all the AI people are there. So I mean, I'll give you both. So, but
Uh,
LinkedIn, I don't know the last time I logged in on LinkedIn. That place horrifies me. There you go.
Perfect. ठीक है. My codex got limited and it only opened June 3rd. So what will I do? You can use a new account. I bought Chat GPT Plus for this. MVP. Okay. I have fake pinging for the last 2 days. My God. What do you mean by that, Pratham?
I think they are pinging some other on LinkedIn.
On LinkedIn. On LinkedIn. Okay, got it. Got it. There are 3 fake profiles on Om Asnani. Uh, I'll show you guys my LinkedIn profile also. This is okay. Perfect. Perfect. Hey Siddharth, I'm building world's first agentic AI based Earth observation platform that make the manual GIS workflow of 48 hours to just 10 minutes. And this has so much potential, like organization pays hundreds of dollars. Way to hundreds of in these reports, and I found a way to collapse the timeline to just 10 minutes. Okay, so that was a statement. Aditya, any question that you would have? But
All the best.
yeah. Okay. You know what I'm listening to you
Keshav,
now?
go for it.
Uh, Rudra is saying, I'm listening to you now, vibe coding my hackathon, making Maggie. Also, it's amazing. Okay. You're speaking to an agent itself. How do you manage context issues in Corex? I use Plus subscription and I have 200K context limit.
I've never had context issues with Codex. Its compaction works great.
Uh, yeah, okay. Anything else?
In between, it was like weird for a couple of days. I think a couple of days it was doing strange things. Like it, but Codex, I usually don't even notice. Like it ran like it quite decent at that.
Got it. I'm using Codex on OpenRouter API. So how do you plan to track it? If you're using anyways Codex on OpenRouter API, your OpenAI ID will be able to understand it. I forgot to fill the daily update yesterday. Will it affect? No, it won't. For Siddharth LinkedIn, it requires his email to connect. Yeah, I mean,
Oh,
one of the never opened it for years is that is why you should connect on Twitter. He's faster.
I have down my LinkedIn so much. At one point in time, I deleted it, but then we had to hire, and we had to make the account again. If LinkedIn managed more, I wouldn't even care. There you go. That's my email.
Yeah.
Any
Uh,
question why any reason why my question? I'll come to your question. I have not noticed your question. Why Codex is better? Is how Codex is better than NT? So I've been using anti gravity. My issue is um, Gemini 3.5 Flash Pro and 3.3 Pro. It was great, but only for certain things. For example, I think Gemini is unmatched on 3D skills till date. But times I have to use 3D is very little. So, but any day I think of 3D, I'll even open Gemini app and it does a great job even there. I don't think anybody has cracked 3D that well, or anybody's even focusing there. 3JS, particle system, particle animations. I'm a Gemini person there. That is one according to me, but usually my usage of anti gravity has dropped drastically. I've noticed lately, like mostly like open code and like on T3 code, it's open code, cursor and codex, and sometimes Claude. Yeah, that is what my rough usage is like.
got it.
Whenever I
Uh,
use Codex to take or make a vibe coding an app, like it's a scenery, and Codex makes doodle instead of humans. So like Codex can't see, or we should use Codex can see. Try the I mean, it can't technically see, but without getting into technicalities, um, try to use computer use to and give it a reference of what you're talking about. And if you want images, it might do well to prompt for image generation, right? Image generation is slightly different than uh, drawing sceneries with code. If you want sceneries from code, then specifically, ask for that, right? But yeah, that is if you're vibe coding it, don't try to put everything in one prompt. First get the basic structure of the app running, and then prompt for the complex thing where you know it's failing. If you know it's not able to put scenery in one go, keep a separate prompt just for scenery. And if it fails, ask it why, what happened, right? That is usually what works.
Got it. Pratham, does the ChatGPT Go plan give any benefits to Codex? No. It would give you slightly more
No.
limit than you normal have, but no, not any other thing. Sheikh is asking, I'm using GitHub and Wurzel. Can I submit that instead of Codex? My machine is having issues when I use Codex and limit is hitting, so I'm using. Yeah, you can submit. So that's fine. Okay. Vijit, huh?
Where you went for college? I went for college in Chandigarh and I dropped out in second year.
I dropped out exactly the next semester after you, but a different college in a different year, definitely. Uh,
Yeah, yeah.
so Vijay is asking, did
So
something?
we both are college dropouts, huh?
Oh, wow. Yes, actually.
We never completed graduation and shit like that, and I'd never even looked back.
For my parents, I'm still supposed to clear my backlogs. So we never had that official conversation, but yeah.
I know. And my dad was I think for first 6 years, he was still like, correspondence. You can get a correspondence degree. You can
Yeah.
just finish your degree. They'll still take you back. And I'm like, yeah, I'll see about it. I'll see about it. Now he doesn't ask.
So when I dropped out, I enrolled for a open university so that I think that my education is going on, but I started working and then I never looked back. So yeah, I still have the books, but yeah, uh, perfect. Yeah, let's come back to this. We can have when my codex limit exceeds or gets over, I use anti-gravity. Would it be fine? Yes, it would be fine. How old are you guys anyway? Keshav, not the subject of the matter today. We'll come to that sometime later, possibly. What if we need some but not so old? Yeah, I can tell you that. What if we need some API, but we can't get.
I'm ancient.
Yeah. Okay, perfect. Trying to get in touch regarding some advice, unable to connect on X or LinkedIn. Any other way I can connect? Uh, Rakshit, I'm sending you my email. You can send it to me and I'll pass it on. You can do that always. Hi, Siddharth and Om. I'm building a natural language schema. One second. This is by Harsh. Huh. Schema Migration Engine and Developer Studio. Right now, it's hard linked to an ecom sandbox to demonstrate its capabilities, but it creates 4 core layers of an app. Such a long question. For the next phase, the goal is to expand this into a universal feature integration engine. I plan to allow users to link any local folder or GitHub repo and visually map scientific specific agents to designated files and directories This gives developers fine-grained control over exactly where and how it changes. Great, great. There's such a good explanation, but I thought there would be a question at the end. The thought process, how you are doing it is great. How will you achieve it is what should be thought about.
No, my second question is also, it feels like part of it feels like reinventing Git. So maybe I don't understand. Maybe you need something we call as elevator pitch, which if you get in an elevator with somebody, lift with somebody, by the time they reach their floor, which is roughly 11 seconds, you need to be able to communicate your idea exactly what you're trying to do. And it's not only a test of your communication, but also your clarity. So you might want to work on the elevator pitch. I have realized whenever my elevator is not clear, even what I build and the instruction I'm giving to agents is also not that clear. Elevator pitch is a great hack, I feel, which might be helpful, right? You should be able to get your idea across in one sentence.
Yeah. Sagar says, can you guide me for this? I'm currently building Life OS, an AI-powered personal operating system that helps user manage knowledge base. Okay. While this significantly accelerates development, I've encountered challenges such as context drift, feature bloat, architecture inconsistency, file explosion, and loss of product focus during long coding sessions. These are becoming important engineering problems as AI-assisted software becomes more common.
This is not an engineering problem. I would disagree. This is a product problem, and specifically scope creep problem. And specifically, like you've described your problem in your own question, which is feature bloat. The name itself, Life OS, suggests the ambitious nature of the project. I'm talking like an AI now, but uh, I want you to go back to 1, 2, 3 framework and elevator pitch. Okay. I would advise build 30 small apps that do that each app does one thing well, and nail it till you start using it every day. Then once you have successfully built several such apps, take the ambition of combining them into a Life OS. But if you start and step foot with a project named Life OS, and trust me, each vibe coder here, including like engineers who discovered like leverage of using AI, all of us have attempted one or the other version of the all doing software. Any of you folks, those, how many of you have tried to build the app, does your work, does your Slack, does your email, does your calendar, keeps an eye on this thing, keeps an eye on that thing? How many of you tried to build the Life app? Please raise a hand in the chat. Okay, because which one of us has not tried that? And in every single case, I know it has been a remarkable failure. Even the people who were like, no, I will build it, they built it. Ask them if they use it. They don't. Okay, because what you're trying to solve is life itself, and the answer to that we all know is 42. Okay, Hitchhiker's Guide to Galaxy reference. Now my only suggestion is, I have seen people have better success when they build mini apps to do only one thing, only and only one thing, started using it every day. That app became closer to their envisionment of all doing OS versus actually attempting it. This is not to discourage you from approaching it. This is to tell you that you are like all of us. I relate with you because I've done the same thing. It's not like it was complete waste. I learned a lot of things. And the biggest thing I learned, A, 42, and B, I learned that it seems right because everything is there in our head, but you can't make an app do what is happening in your head. And the deeper you will go into it, the more confused you will get. Instead, build mini apps. Just does one thing that irritates you, which you don't want to do. And that way you will actually end up building the OS of your dreams. That's my suggestion. But I know when you're in that phase of building the app, nothing anyone say will convince you, which is the rite of passage. It's, as we call it, what is the name of that? It's canonical movement. All right. It's canonical event. So we cannot interfere with the canon event. And so you must have your canon event and then build the mini apps, right? All of us go through this. Which one of us has not attempted it? All of us have tried to do that. This app will solve the world. It will solve world hunger. Yes, it will. All right.
Got it. The RSS feeds are fetching successfully and article data like title, image, and description are displaying correctly. However, when users click on an article, the link is not redirecting to the correct destination page, and in some cases, it opens a 404 wrong article homepage or invalid redirect URL. Interesting. Maybe because it is just giving or directing it to RSS feed itself and not the original link. But why would that happen?
It's possible.
Hmm.
I mean, you can
Just
ask
like
it to open it in its own browser.
yeah.
But ask it to open in your own browser. Ask it to click the link and ask it to explain what's going on. Why is it? Or send a screenshot to it.
Hmm. I have built and completed my agent to agent negotiation marketplace for MSMEs to remove sales friction entirely. I have used very less codex would affect the judgment criteria. It would be judged based on the impact of the feature that you have built and not just the complete usage of it. Rudra has 10 questions, but all are same. Why? That's why he's spamming. My app needs API to work. Do I need to include my own API key? Yes. Yes, you need to include your API key to test. You don't need to give us your API, definitely. But yeah, if it's working for you, that's great. We'll test it. Building entire hiring process in one app. How is that instead of going to Naukri like that? Yeah, one workflow specifically for hiring would still make sense when you want to solve for it, but you still might need human at a lot of places there. I'm building.
Arjun, calm your horses.
क्या हो रहा है? Oh wow, okay.
Spamming this
Arjun,
question. I'm reading it and he's all
yeah. So Arjun,
like,
thank you for spamming. We'll come to that in 10 minutes, right? So please,
yeah.
there are so many people in the chat here. If you want attention, we can take the names, but please, right? We will lose memory. Your question is about memory, so please. I want to talk about the potential of my Terra query, world's first agentic AI based EO platform after the hackathon. Okay, what happened? The question just went up. 1 second.
Zoom is not built like YouTube. On YouTube, it's so much easier to read these questions at any speed.
Yeah. I'm building, okay, we'll come to that. I'm building WipeGuard because 45% of AI generate code ships with security vulnerabilities and nobody catches it before production. WipeGuard automatically sends every PR, gives a trust score and blocks unsafe merger, no manual steps, fully automated. Interesting.
I hope you're aware of prompt injections, and I hope you will test your app against it.
Got it. Rhythm is saying, by the way, I've cracked the code to use Codex Unlimited, by the way, and I've been using it so far like that.
You don't go talk about that kind of stuff out there.
Build a YouTube video, share the link, we'll share it with everyone. I want to talk about the potential of my Terra query, world's first agentic AI based EO platform. After the hackathon, is there a way we could discuss? We'll discuss that after the hackathon. So let's build what you have right now. Once you submit, we'll give you that option in the form and see if there's something that we could do. Amar is asking, how do we make architectural decisions with AI?
Ask it for, this is a good tip. I recently learned it. Ask it to build a HTML page where it gives you all that option and discuss with that. HTML. Ask it to build a page for architectural decisions.
Got it. Hi, Om. I want you to give feedback on my idea as a senior developer. I'm building NoderFit, a workflow automation platform where you describe what you want to plain English and agents build runs the workflow for you. Currently, I have added HTTP and trigger nodes just like Anyten. Now in the next step, I have to add some more nodes like Gmail, WhatsApp. I'll add chatbot, which will build my workflow by just chatting with chatbot. That's a good line. Tell me how is that? This is Aman Srivastav. Yeah. Hi, Om with a hand emoji. Can you?
Wow, there's so many questions. I don't know how to keep track of these.
Yeah. Okay, but that is only because people are spamming.
Yeah, we won't be the right audience unless you're building and targeting specifically us. We are not the right people to opinionate about the idea, right now. um, when you're building an MVP, you want to ask this question to your customer base. I might think the idea is great, but if I was the genius who could predict the idea's success, then I would be maybe, like in a different place. But it is not like something that I claim to have. Uh, we collectively judge your idea to be bad, but you have great idea. It's full of such cases which people rejected and it still turned to be great. So in the end, um, if it wants to make money, or customer opens their wallet and pays you money, then you're right. It's like that. You want to ask this question to your target audience closer.
Got it.
I'm
Their
building memory layer
content
for
is
big enterprise where they have too much documents, an index layer, agent to access information. Yeah, and what you're describing, agentic RAG. Search for that.
wow. Okay. Interesting. So, folks, thank you for sharing your ideas in very detail. And there are so many explanations of it. Uh, it's difficult for us to respond to every one of it because you are the judge of your idea. One, we can just help you with the execution of it. Who am I to tell you if your idea is good or bad, right? So we'll keep it to that for all the questions of how's my idea, is this
So
valid?
we can't do the judgment round here also, no? That tell me if the idea is winning or not, then I'll build it. Can't do that, right?
Got it. Siddharth, do you want to read the Rudra Pratap Singh's long one? I'll read it for you, and you might. So one, Rudra is building Munshiji AI is an AI powered finance operating system built for Indian MSMEs. It simplifies invoicing, GST compliance, expense management using AI. Users can create invoices, AI extracts, and does the full flow of things. Oh yeah, okay. There's also an idea explanation. Rudra would appreciate a voice-enabled workflows make finance, chat history, and contextual memory. Business can send invoice. Okay, interesting.
The reason
Can you
he
review the?
pointed that to me is why, folks, I have an app called Munshiji. I have 10 apps called Munshiji. I've been trying to build Munshiji, not the version he's trying to build, my own Munshiji for how many years, Om? I told you 10 years now.
Yeah, about that time.
Yeah.
Yeah.
I relate. I relate.
Now they'll know how old we are. Uh, as I'm filling the gap between the printing and image generation, the image is generating, but when I was passing the image through the engine, the image is dropping the colors as I export it on my CMYK. Can you tell which tweaks I should do in the conversion engine?
You are taking RGB and turning into CMYK. There are standard translators for that. So use any of that standard setup. But you will not have the same color in CMYK. There'll be differences.
Got it. My project is Agentic Innovation Platform, launch hackathons using. Okay, perfect. Okay. What if we need some API, but we can't get access to them? Can your team help us with that? Unfortunately, no. How should we present our project? I'll cover that in a bit. I'm building a chatbot. Interesting. Uh, if you can also answer mine. Yeah, but okay. I'm building a GBot, an AI-powered system in an AI-powered system in Unreal Engine. One major problem in game dev is that building worlds manually takes a huge amount of time and effort. Gbot solves this by taking natural language goals like building a fortress and automatically generating structures inside the game world. Right now, I'm focused on making it smarter, scalable. Okay, perfect. Good luck, Nathan. Help me with how can I fix UI UX design of my app? Used multiple models to code, but design, I liked what Claude Code gave. How can I merge the design from Claude? Okay, where is that question? Claude design to Codex.
You can ask Codex to
How-
take it up and merge it for you.
Yeah. So Amit, what you could do? No, this was not Amit, my bad. The question just flowed up. Okay. Yeah, whoever basically asked, whatever design you have on Claude design, export that, give it to Codex, ask it to understand, adjust the color framing and how the format is, and it would do it. Santosh, yes. Okay. Gaurav, good idea. Do you think malware triaging is still relevant? Okay, 1 second. Perfect, folks. So what we will do now, most of the questions which are coming up is basically idea reviewing, which we already answered a couple of times. So what I'll do next is I'll answer a couple of logistical questions that you have. But for that, what we will do is 1 second. Perfect. Perfect. So with that, we would have Siddharth leave for the day. Because anyway, we were also sort of, blocked this time for 9 p.m. itself. It's 3 minutes to go. So any final words for Siddharth? Any final words for Siddharth in chat? Did you like what he taught? And yeah, in the chat, you can quickly drop that. And then we'll come to our logistical questions.
You folks, looking forward to what you're gonna build, and thank you so much for being an amazing audience.
Perfect. Thank you so much, Siddharth. We'll see you soon again. Perfect. That was Siddharth. That was Siddharth. That was Siddharth. Did you enjoy this? Did you enjoy understanding MVP scoping out? Did you understand how do you look at, building a product? Okay, perfect. 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 Now, do not spam in the chat, but ask all your questions that you have in the chat. This is about submissions. This is about hackathon. This is about a lot of other things that you might be struggling with. I have been trying to be active and respond your questions on the WhatsApp chat as well. Saurav is asking your presentation link. Make sure access the
everyone.
Recording in progress.
Good morning, good evening, good afternoon, depending on from where you are joining. Welcome to this hands-on lab and the webinar on building video curation pipeline with Ray. My name is Suman. I'm going to share my screen. Give me 1 second before we get started. Okay, so I guess you are able to see my screen. And give me one moment before we get started. I just want to set a few things up. All right. So I can see. Okay, perfect. So I can see the questions, and the chat. So let's get started. Okay, so once again, thank you so much for joining this webinar and hands-on lab. What we are going to do today is we are going to learn about how you can do a video processing job, or more specifically, video curation with Ray. So this is one of the projects that I've been working on last couple of weeks, and hopefully I'll have some blog around that in the upcoming weeks. But I just want to share few of the learnings and how you can build a multimodal video curation pipeline with Ray. And this is something that you would generally do or typically do before training a multimodal model or any language a video model or VLM. So before we jump into the code and see the demo, I just thought to give you a brief about array data, because that is what we are going to use in this particular tutorial. So before I start, if you have any questions, feel free to ask in the Q&A tab, or you can put that in the chat, or at later point in time when you start working on the notebook, which I'm going to share. If you have any questions, you can always reach out to me later on. Okay, so in case you are new to Ray, Ray is a unified compute engine which works on top of any cloud platform. In fact, it can work on your laptop as well. So the way that you can think of Ray is the moment you have Ray on your infrastructure, you have the power to distribute any AI workload or any AI application. So in today's demo, we are going to focus on array data, which is a higher level abstract API or library on top of Ray core, which is intentionally built for data workloads. But apart from Ray data, we have Ray train for training, Ray tune for hyperparameter tuning, and so on and so forth. But at its core, under the hood, it uses Ray core, which is the core library, which helps to scale any software application written in Python typically. All right, so today we are going to look into array data. Now, if you think about data engineering or data processing traditionally, these are the different use cases that we see mostly people use with Ray data. One is the multimodal data, where the data has different modality like images, text, videos, etc. And people use array data to process a huge amount of data at scale. And that is what we are going to see today when we process thousands of videos at terabyte scale. And we'll see that how array data can help us to process that in the pipeline. The other use case is how you can do offline inference. For example, if you have any recommendation engine, or if you have if you're working in a media agency or editing farm, you might have to do generate a lot of embeddings, and that is being generated offline in batches. So that is where you will use batch inference. And of course, you can always use Ray data with a Ray train for your training, where you pre-process your data as the data comes, and you take the stream of the data for your training. So we are going to go over how this streaming works in a while. But these are the typical three different workloads that we see where people use array data. Okay, multimodal data processing, offline inference, and training ingests, or working with Ray data at the time of training. So if you look back, we had many different architectures and frameworks to work with data. We have seen how to work with structured data, typically on the CPU using Hadoop, and that worked pretty well for structured data, although it has a basic constraint that you have to work with the Java application. It's more native to Java, but it worked pretty well for a large-scale distributed data workload in early 2000s. Later on, we moved into Spark, which is again for structured data typically, and again, it's based on Java, and we typically used a CPU for processing the data. But if you think about it today, or in last few years, the dynamics of data have changed. So the structured data is now became more multimodal, like video, text, LiDAR data, MCAP, robotics data, and all of that. These all are very unstructured. It's not typical, data which we get in rows and columns. So you need to do, your engine should be able to process that data in a certain way, okay? So that it can be consumed for training or any downstream processing. And then this is, in today's world, data is more agnostic to CPUs and GPUs, meaning that your data should be, your infrastructure should be good enough to process that data on CPU and GPU both, because few of the processing might need CPU, few of the processing might need GPU. And that is what we are going to see when we process a particular video. You can imagine that you take a video from YouTube, and now let's say you want to use that video as a data point in your training. How will you do that? You cannot just feed that YouTube video directly to your VLM model training. So when we look into what are the steps that we do while processing that video, you will realize and appreciate that how important it is for us to have a platform which can work with CPU and GPU both, and in the most efficient way. And of course, people are more aligned to an engine which is Python first. Right? Unlike other frameworks, we need to have some framework, some engine which is more Python native, and that's where engines like, or frameworks like VLLM, PyTorch, Ray, all of them come together because these are the engines or frameworks which works natively, and it has its native integration, which allows developers like you and me to process the data without any hindrance. Now, this is where Ray data comes in. Now, if you think about Ray data, how it looks like under the hood, it's something like this, okay? And we are going to go deep into this, but I just want to give you a notion of Ray data in case you are new to Ray. The way that you read a data is like this. You import Ray and then just call ray.data and let's say read images. Just like this read images, we have different APIs like read Parquet, read CSV, and so on and so forth, just like how you do it in Pandas. So the learning curve is pretty minimal because you are getting the APIs exactly how you would like to have if you are using any of the data frameworks. So once you read that, what you get is this data set is not a local list or a pandas data frame which is sitting on your laptop or one machine. This is a distributed data set. This is a file which is split into chunks across multiple nodes, which is ready to get processed. Okay, but how it is doing, right? So this is the core primitive. Like when you define array data, it's actually an object across multiple nodes, right? And you can process your data at scale. And this is how it works under the hood. So if you think about it, if you consider a data like this, where you have lots of rows and lots of columns, the way that Ray data will process this data set, and imagine that this data set is of size hundreds of GBs or TBs. The way that it works is it will split the data into blocks. So the way that you can imagine is that this is the block on which you can do a certain operation. So this is the minimum amount of data which array operates. And a typical block size is 128 MB. Although you can add a lot of change a few of the things and make some configuration, but this is ideally what developers use. And what happens is when array data chunks that data in this format, what this allows array data to work on is you can do any operation in parallel in all these chunks. So imagine that you have thousands of videos or thousands of images, and you want to do a certain operation, let's say cropping of the image or generating the embedding for that image. The way that you can think of it is array will do that at scale at a block layer. So all the rows within that block will be processed, and you can get your job done in a much efficient way. Okay. Now, that's about array data, how you define it. But the beauty of array data is it's so Pythonic that it will feel very native to you. And the way that you stack the transformations are as simple as this. So you start with a reading, let's say from pandas, and you can define your path. And then you can perform or chain your transformation. You can define which column of this data set you want to download. You can perform some image processing, like in the third line here, when we say map batches, where it takes a batch of data and it will process. Similarly, you can do the next processing with embedding, and then finally write the data. The best part about this pipeline is it works in a streaming fashion, and it doesn't load the whole data set to your memory. And another beauty of this is when if you remember just a couple of minutes back, we discussed that your engine should be agnostic to the accelerator or the hardware, whether it's CPU or GPU. Now, if you think about this pipeline, it might happen that this batch operation needs a CPU, and this batch operation might need a GPU, and write parquet would typically need a CPU, right? You will not want that process to be run on GPU. So within this line of code, you are actually using different accelerators, and you can define exactly on which GPU you want to work on, how you want to scale it. Everything is something that you can configure. And that's how your data set can work across multiple CPUs and GPUs of your choice. Okay, so that's about array data at a very high level. Now, I talked about streaming, right? So, and we talked about that it is not going to read the whole data set in your memory, right? So how does that work? So in a typical streaming, you load the full data and then perform a transformation. Now, this can be, let's say, a transformation like a cropping of image. And this might be segmentation. And then finally, you might have to generate some embedding, right? So you do it in a sequential way. And what end up happening is your GPU stays idle till the point that it actually needs the GPU. But with array data, what happens is, if you remember, we defined that array data works at blocks. So the moment a particular block execution is over, so in this case, let's say this is the first block. This is the first block. This is the first block, and this is the second block. The moment that first block got loaded, what it would do is it would start the processing of the next transformation. So when this is happening, at the same time, the loading of the second block is happening, right? So that's how what end up happening is you are able to use your resources under the hood in a much efficient way, and your CPU utilization increases. And that is what we are going to see in our video processing task, where we will be performing multiple different transformation, and every transformation would need different resources. Some step would need CPU, some step would need GPU, and we will see that how we can scale each of these transformations independently. Right? So that's about the streaming workload. Okay. Now, coming back to the demo, what we are going to do today is we are going to curate the video for, let's say, a video processing, a video or VLM training job. So we want to train a VLM model, and before that, we need to prepare the data set. And today's webinar is more on this preparation of the data set. And the data set that we are going to use is a fine web. I'm going to show you that data set. That data set is available on GitHub. On Hugging Face. It is a very popular data set in the field of video curation or VLM training. And what we're going to do as part of the processing is we will first ingest the data, then we will do some screen detection, and a lot of other things in this particular step. Then we will find out quality check the frames or these clips which have higher quality. We will just take that. So there will be a quality filtering. And then finally, we will do some segmentation filtering and semantic filtering. We'll add some captions and all of that. And then finally, we will generate the embeddings of the clips. So if you think about a typical pipeline of a video curation, this is how it would look like. In fact, you can add more transformations in the middle depending on your particular use case. But it happens generally in this sequence. Now, with array data, what we are going to do is we are going to do this using array data. Okay, we will use array data read Parquet to read that data set, and it will be read directly from Hugging Face. So we are not going to read it and store it on S3 or anything like that. We will read and stream directly from Hugging Face, and this will be done in CPU, and then we will process it one by one, and we will use different APIs of array data which can do all this transformation. And the point to note here is that different transformations are using different types of resource, right? And that is something that is very important to note. And the next point is all of this all of this transformation can scale independently, right? So let's say this this step, let's say semantic filtering, this needs a GPU, right? So if we want to define that there are two, it should be always run in two instances. But to make two instances, we need to make sure that the GPU in these two instances are always busy. So to make this GPU busy, I want this previous step to be very, very efficient. That means I might have to spin up, let's say, 10 instances of this, or I want to scale this with 10 CPUs so that it is good enough to make sure that it can saturate this GPU, right? And whenever the GPU is fully utilized, I should have the control such that I should be reducing this previous stage to, let's say, just 8 instances. So the point I'm trying to make is with array data, you have the opportunity to scale every transformation independently, and under the hood, array will take care of this automatic scaling with back pressure. So it will understand if there is the previous layer is pumping data a little too hard, so it will automatically snooze that, and it will scale down depending on the pipeline. Okay, so that is what we are going to do in this demo, and we will now see in the notebook what these steps does one by one. Okay, so I think there is some question. What we do in the filtering? Yes, that is what we are going to see. That what is the difference between array data and PySpark data frame. Yeah, so PySpark is like when you think about Spark data frame, it is also used for distributed data processing. But as I mentioned, Spark is more for structured data, and it is not that agnostic by design for GPU and CPU. And with Ray, it is more agnostic to your AI workloads, right? So that is one of the use case why Ray is predominantly used for any AI workloads, be it data processing or training or inference. And the second thing is that the streaming execution is what makes it very, very efficient, because every let me just show this one more time. So if you see here, with every transformation, right? So after every transformation, the data is do not get destaged. That means, let's say, I'll take this image. So when you work with this, typically, after every transformation, you save the data in some backend storage, and then you read from there, and again you write it back to some sink. So you always do that in a typical pipeline. Whereas when you use Ray data, we have a construct called object store, where it is a part of the RAM or the memory, where the data transformation happens, on the fly from one stage to another. Okay, so you don't have to destage your intermediate steps every time, and that is what we are going to see in the demo. Okay. All right. So now let's go to the notebook. All right, so before we get started, I want to quickly show you how I have come here. So if you have created a notebook, or sorry, if you have created an Anyscale account, after you log in, you will end up coming here in this dashboard. And what you can do is you can come to this workspace and click on create a workspace. And when you do that, you get two options. Either you can create from a template, or you can create from a blank template. Now, if you click on this blank template, you can just give any name, let's say demo, and keep everything as is. You don't have to change anything. Just in the worker node, this is where your actual processing will happen. Just change the worker type to A10. Right? You can use, let's say, A10 32 CPU. That's all. Once that is done, you can simply come here and click on create. You don't have to do anything else here. And once you do that, what will happen is you will see your workspace here with some random name. And then it will be not with random name, sorry, with the name that you have defined. You will get a random string if you create from a template, because we spin it on your behalf. And then it will be in the initialization stage. And once it is in the running stage, what you can do is you can simply click on the workspace, and you will end up coming here. And if you see on the right-hand side top, you will see how many CPUs and GPUs you have, how many worker nodes you have, and so on and so forth. Okay. Once you are here, you can come to this Visual Studio Code, and this is where you are going to run your notebook. So the way that you can imagine this space is, this is an IDE on the web, where you don't have to worry about creating a cluster and all of that. Everything Anyscale would do under the hood, and this is how you can leverage Anyscale to do some prototyping, testing, and etc. Right? And once you are here, you can clone this repo. Let me just 1 second. I'll just show you the repo. Yeah, so this is the repository, and I'm going to share you the link, but you can do git clone. This is the repository. Okay, so repository is GitHub Anyscale video curation. So this is, let me just put that in the chat. Okay, so this is the repository you have to clone, and once you do that, you will see this video curation on your left hand side. I've already done that, so that's why I see the notebook here. Now, what I've done is, just to get a more space to present, I have clicked on VS Code and opened in a new tab. Okay, so you can always open in VS Code or in Cursor, but I just opened in a new tab. And if you see here, if I go to the next tab, I can see the same space, the same notebook, sorry, the same IDE here, but with little more space. So now within this, you will see one notebook. I've just copied it. I'm calling it as Ray Data Video Curation Pipeline. You will just see one notebook. You can just run that notebook from start to finish. Okay, so this is the setup. This is the lab environment. You just have one notebook and one .py file. You can read through that at later point in time, but I'm going to go through this notebook now. Okay, so there were some questions. Venkat is saying I was late. So yeah, sure. I think I shared that link, and it's there in the chat. You should be able to see that. But don't worry about that. You can just follow along. Somebody's asked, can we create a blank? Yes, you can create a blank workspace and just clone and get started. Okay. All right. So let's see what we are going to do in this video curation pipeline and how we do that. So we have already talked about what are the different stages. And now let's see how we can do this. So first, I will install a few of the libraries that we are going to use, like Hugging Face, Decode. This is one of the libraries that I'm going to use to read the video data. If you are aware of FFmpeg, it actually uses under the hood, but I will tell you why I'm using Decode. Okay. The second thing is I need to check that I have the Hugging Face credentials, because the dataset that I'm going to use is this one, which is Hugging Face Fine Web dataset. And it contains, if I just scroll down, you will see that it contains more than 47,000 videos with an average length of around 5 minutes with 3,400 hours of content, right? So it's a massive data set. And in our demo, we are going to use just the first 20 data points just to see that in action in the notebook. But I'll show you how we can run this for the entire data set. Okay, and that is what I have done by running the same code as a Anyscale job, which I will touch upon at later point in time. Okay, but the point I'm trying to emphasize here is that the same code, which is now which we are going to see now, which is working on, let's say 10, 20 videos, it is going to work the exact same way for 30,000 videos or 40,000 videos, right? So you don't have to worry about that. Okay, so that's about the authentication. So you need to have a Hugging Face token because this is gated dataset. I'm just checking whether this Hugging Face dataset is, Hugging Face token is uploaded or not. The next thing to check is the array initialization. This is just for your understanding, just to see how many GPUs that you have, how much memory that you have, just an auditing of the cluster. And if you see here, you see that we have 2 GPUs, 72 CPUs, and so on, right? This is exactly the same thing which we have seen in the UI here, right? It's just a programmatic way to see that. Okay, so before I show you, if you are new to Ray, I'll just show you how Ray works very quickly. So typically, if you want to scale any application, let's say this is an function, how you can convert that into a array task, which is one of the construct, is by using a decorator array.remote. And then if you call this function, typically you call this function by just passing the argument. But when you decorate it with array.remote, the way that you will call it is the function name dot remote followed by the argument that this function needs. Okay, so this dot remote is something that you need to add when you decorate any function with array.remote. And what would happen under the hood is array will create tasks on your behalf. That means in this case, we are running it for a range of 8. That means 9 numbers. So there will be 9 tasks will be created in the cluster. So the way that you can imagine is it will try to find 9 free CPUs in the cluster, because here we have not defined whether this should run on CPU or GPU. The way that you can define it is you can just say num CPU let's say equal to 1 or 2 or whatever. In that case, it will just try to find that many number of CPU or GPU. In this case, I have not defined anything. So that's why it will just by default pick one free CPU in the cluster. So it will just spin up all these 9 threads in the cluster, and it will get executed at the same time. That's why, although this function sleeps for half a second, you will get the response back altogether, once it's all done. Okay, when you run it for the first time, it might take a little bit of time because your array will be initialized, but it will take some time. But this is how array scales your Python application. So this is about task. Because this is independent, right? So every call is independent to the next call. So there is no state here. So this is useful for stateless application, whereas Ray Actor is for stateful application, where you want to have the state. For example, for stateless, one of the examples that you can think of it is, let's say you want to crop images, right? So if you have 100 images, you just want to crop 100 images. Now, this is a very stateless task, because every image crop has nothing to do with the next image crop, right? So you can create a task, and all of that can happen independently. Whereas an example of an actor would be, let's say you are doing a model training where you need to update the model weights. So model weights need to be uploaded once, and it should be changed across all the data points, right? So you cannot just change the model's weights independently. Also, if you want to use any model for inference, you may like to load the model and keep it in the memory, in the RAM, and then perform all the inferences by using pointing it to the same memory, so that you don't consume the memory for independent tasks. So this is where you will use array actor, where you have a state requirement. Just like this, I am calling this the instance of this class, and the way that you call it is exactly the same way. And what is happening here is it is updating the state which we defined under this constructor, right? So that's the only difference. Ray task is for stateless, Ray actor is for stateful application, right? And the way that you should mentally think is Python functions are meant for stateless, and when you convert that into a Ray object, it becomes a Ray task. And Python classes are for stateful application. When you convert into a Ray object, it becomes a Ray actor, right? All right. So now let's see how we can make use of array data. So you don't have to decorate every function to create tasks and actors, although you can very well do this. But as I mentioned, if you remember earlier here, what we discussed about is array core, right? Where you define the actor task, of your own. You get a more granular access. But now we will talk about array data. Now with array data, it is built on top of array core. So you don't have to decorate a function and with array.remote and all this. array data will take care of that. Okay, and let me show you how array data works. So here I'm just creating a data set by just a list of numbers. And now you can perform different functions, right? And different transformation. And every transformation actually creates either an actor or a task, right? And they all can scale independently. But see this here, I just have a lambda function, but think of it like you can have any function which you have defined, and Ray will take care of scaling. Right? And each of the stage can be scaled independently, and that's what this image demonstrates. Your first transformation might need 4 CPU. Your next transformation might need 2 GPUs. So it can be scaled independently. And with back pressure, Array can take care of how to scale and how to descale these different stages. Okay. Now, if you think of array data, or if you have got some basic understanding of array data, let's now get into the video curation pipeline. Okay. So what we are going to do is now we are going to read the data from Hugging Face, and this is going to use a CPU. And then we are going to do some transformation like screen detection, quality filtering, and generating the key frames. And that is what I think somebody asked, what we do in screen detection. That is what we are going to do. And then we will use VLM for semantic analysis and other stages. So I'll go over all these one after another. Okay. Now, before I show you the pipeline, I want to emphasize one thing. I'm going to show you every stage and its output so that you exactly know what is coming in every stage and what is coming out. So this is just for interactive learning. But at the end, everything from start to end, we will run it in one cell in this Jupyter notebook, so that you appreciate the fact how this data processing is happening in stream. But we will go through step by step and see the output just for our visual understanding. Right? Okay, so first thing is we will define few of the constants which we would need, like what is the path of the data set, how many videos we want to read, and where we want to save the final curated data. This is the data set which we will use for training or any downstream processes. Okay. And there are a few other constants that we have defined, and I'll get back to these constants at later point in time. But see this, I'm importing this stage method. So if you see this stage.py, this is the .py file where we defined all these stages. Okay, and I'll come back to this a little later, but we will be using the methods that we have defined here. In the notebook, our focus is more on how we are calling those transformations, but the logic of those transformations are kept in this stages.py. Okay. So first, let me just show you the first stage. Okay. So we have total 5 stages. So we'll start with the first stage where we read the data from Hugging Face. Okay. Now, the way that we read this is using ray.data, read parquet, and we pass the Hugging Face URL. And that data set contains multiple columns. If you come to this Hugging Face data set, you see that there is a column called MP4 and there is a column called JSON. So we are interested in reading this MP4 column. And that is why we are mentioning MP4 column. And we are saying that only to accept Parquet files, because it has, if you see the other, this is not in Parquet, it's in JSON. So we want to read only Parquet datasets or file extensions, and we just define the file system. Once you have this, at this point in time, array data is not going to do anything. So array data by default works in a lazy execution mode. So it will not do anything. And what we are defining here is when we say array videos.limit, we are just saying that you should always only read the number of videos that I define. So in this case, we have set this constant to 20. So it will just read the first 20 videos. Right? And later on, we will see when we submit this as a job, not through a notebook, we can define the number of videos. So by default, it will just run for the entire data set. Okay. And if you see the schema of this data set, it just have one column, which is MP4, and it is in binary format. So if you see this data set, it is a binary formatted data. So every row is one video. Okay, and the way that you should think about it is that video is a YouTube video. You have encoded it into in the binary format. All right. So before I proceed, I want to show you how this data looks like. So this is the data set. I am taking the first video, and that is what I'm calling it as a sample. And I'm just showing you how that data looks like and what is the size of that data. And if I scroll down, you will see that this is coming from MP4 column. It has this many bytes. The size is around 2.7 MB. So this is the first video, which is 2.7 MB. And this is how the data looks like. Okay? It's in binary format. So if you change the index, let's say you see the next video, the size of that video would be different. Okay. And just to see how it looks like, I'm just trying to read the video file, and this is how it would look like. And you can always change. This is I used that 200 frame, but you can always use any video, and you can just experiment and see how that frame looks like. I'm going to use Decode, as I mentioned earlier, for video reading. You can always use different tools, but this is one of the library that I've seen, which is pretty good for AI workloads because it helps you to render the video, and you can easily convert that into a NumPy array or a tensor, and it is more efficient. Okay, but you can always use any other engine of your choice. So it's completely up to you. So that's about the first stage of reading. So before we proceed, you remember our data set that we have just stored. It's DS videos. Okay, so this is the data set, array data set that I have. So now let's go to the second stage, which is the most important stage. But before that, let me see if you have any questions. Will all the tasks run in a single instance having 72 cores? No. So at this point, your cluster is having let's see how many CPUs and GPUs I have. We have 72 CPUs and 2 GPUs. So now, depending on every transformation, how I want the transformation to run, it will pick up one of the CPU or one of the GPU. If I don't define anything, it will just pick one CPU. You cannot run a task in 72 GPUs or 72 CPUs, meaning that a particular task need to run on some virtual machine, right? So if that virtual machine is having 8 CPUs, you can have a task with 8 CPUs. You might have hundreds of such machine. So you will use maximum 8 CPUs, but at till you reach all the CPUs. For example, let's say you have multiple nodes. Okay, node 1 to let's say node 100. Okay, and every node is having let's say 8 CPU. Okay, so total you have 800 CPU. So you would be able to use all these 800 CPU, but a particular task can take maximum 8 CPUs. Okay, now imagine that you have 100 machines, and you have created a process or task which needs 8 CPU. So you can Ray will create multiple tasks all in parallel in all the machines, but a particular task can just run on 8 because that is the maximum number of CPUs that this is one particular machine have. You cannot have a task across node. Okay, so that's the point. But it will use all the 72 cores when you are processing at scale. Okay, Okay, so other question is, what kind of use case and application? Yeah, I think I talked about it. Ray is more predominant for multimodal data, where you have data like image, text, audio, everything together. Weber is asking, since the video file is at 2.7 MB, yes, that's correct. So in this case, you'll have just one block, because that is smaller than 128 MB. So you will have multiple rows in one block. You remember when we talked about array data, every block here. Yeah, so every block consists of multiple rows. So we just pick the first row. So it is coming from, let's say, block number 1, right? So depending on the size, it will divide the blocks. Okay, so let me go ahead with the next stage, and then I'll again come back to the questions. So the next stage is, we now defined the reading. Now let's see what we will do as a transformation. So in this case, we are doing screen detection. That means we have to detect the screens of every video. And the way that we are doing is, we are sampling every 20th frame, okay? And then we are using Bhattacharya distance metrics. Now, this is a technique that I have used for this. You can always, there's a logic of segmentation, and there are different ways to detect. But this uses histogram-based, statistical segment screen detection. So it worked pretty well. So what it basically does is, if let's say if you have a video with multiple frames, and it will first take the frames, 20th frame, every 20th frame, and then it will try to see the image or the RGB, or the image intensity or pixel intensity of all those frames. And if it sees that these frames are very similar to each other, it will not create a boundary, right? So because let's say there is a video where a news editor, a news anchor is streaming a news. So in that case, that person is just sitting in one place and just talking, right? So, or sharing the news. So you, even if you split every 20th frame, it will not give you any new information, right? So, but how will you define that boundary? Right? That is what this Bhattacharya distance defines. Yeah, it will just compare the probability distribution of two different frames, and it will just give you the value, right? And we have mentioned a threshold of 0.5. That means if one is different than other, and difference is more than 50%, then we should have a cut. We should have a split. So we read this data, which is an MP4 bytes. We will frame after 20 frames, right? This is statically defined. And then we will take the clips from there. So you will end up getting clips like this. And then after getting the clips, I will add a few of the features, like what is the brightness, what is the contrast, what is the sharpness, and all of that for all the clips. And then we will do some filtering based on the value that these features have. And let's say if I want a certain brightness, then I will just pick those images, those frames, and I will discard or drop all of that. And that is what video curation is about. You take the video, you process and discard things which you don't want. And once you do that, you will end up getting the final frames which we can process. And the way that we will do is, after we get the final frames, we will save the frames for the later stage. And the way that we are doing it is, we are having a keyframe for VLM and 3 frames for clip. So every image, so what we are doing is, every clip, okay, for every clip, we will have one keyframe for VLM processing, which we will be using later on, and 3 keyframe for clip embedding. Okay. So first of all, why I am doing it here? One of the reasons that I'm doing it here is, see, we are doing a lot of things in one step. So we are fusing all of this in one step. And one of the reasons that we are doing it, because we don't want to open the file more than once. So we are trying to open the file just once and do everything possible and just close the file. And that is why we used Decode. If you use FFmpeg and any other engine, you might have to read the file multiple times. You might have to read to get the keyframes. You might have to read again to get the frames for clip embeddings. And one of the reasons that I'm doing this is for later stage. Okay, this will be using in later stage. Okay, and which keyframe I am using? I am taking from this clip. I am taking exactly the middle keyframe. Okay, and for this, I'm using the first, middle, and the last. So out of these keyframes, this keyframe is common across both, right? But still, I'm saving it because when I do the VLM processing, the model that I'm going to use, it needs the image in a different format. Whereas for clip, the way that it needs the image is in a different format. That's why I'm still storing it separately. So I'll show you when we see the code. Okay. So first, I am importing the process video byte stage. So this is the first stage from stages. If you come here, this is the first stage, video processing. And what we are doing is we are taking one row. So this is one row of video getting inside. And the output is 0 to n, the number of, and we don't know what is n, but in average, what I've seen is around 10 clips it is generating. And it is giving us all these different parameters, the video ID, clip ID, and keyframe bytes list. So this is used for VLM, which I was talking about, and it demands the image to be in this resolution, whereas for embeddings, this is the resolution, right? So these two is what I was talking here, okay? So these are the two things. So this is for the VLM processing, and this is for the clip processing. Okay. So now I'm just saving this in DS clip. And if you look at the schema, I'll scroll down and see this. We now have all these different features. You know, all these features have been processed, and there are two features that we have added is keyframe bytes. This will be used by VLM in the later stage, and this will be used by the clip embedding. And this is a list of binary, right? So this is where I have 3 elements in each row, where those 3 elements are the first frames byte, the middle frames byte, and the last frames byte. Okay. So that's about the first stage. And now if you want to see this, how it looks like, I'm just printing it out. This is how the data would look like. I have dropped the keyframes because that's binary. There is no point of looking into this. But this is how your clips will look like. You see this? This is the first video. See, the video ID is same, but clip index are different, right? So this is the starting frame, ending frame, and so on and so forth. Okay, so that's about the first stage. I'm just printing the clips. You can always play around when you go through this notebook. Okay. Once that is done, I'm into the second stage where I will be passing this data through a VLM. And this is where we will be using VLLM under the hood. Again, I'm importing the functions which are needed for this particular stage and which is defined under stages. and I'm defining a system prompt and a user prompt, because now I'm going to send every video frames with some system prompts. And the system prompt is like this: you are a video content analyst, analyze the provided keyframe from a video clip and respond only in valid JSON, right? I'm restricting it. You should respond only in JSON. And I'm defining what should be the structure of the JSON. Okay. I'm saying that you should add a category. You should add a field called is safe, whether that content is safe or not. And I'm also adding a description, and I'm adding a visual quality. Okay, these are the 4 things that I'm appending. So the way that you call this is you import array data LLM, and you import the build process and VLM processing configuration, and then you simply create the builder. And this is about if you want to know what are these APIs, you can check array data VLLM integration, where you define the configuration that are needed for VLLM, and you define the model. So in this case, we are using a Qwen model, and then we just define what is the batch size and etc. And these are the defaults that, the static numbers that we have defined earlier. Okay, once this is done, we can see the schema, and we can analyze how the new data looks like, right? And again, every stage is happening at scale independently, right? So Ray is creating actors in this case. If you see this, it has created an actor. Let me go back and show you this. Yeah, so it is reading the data. It is creating a task pool, and it is just defining whatever we have mentioned in our transformation. Okay, so now if I just scroll down, you will see the output. Okay, yeah, see this, it has created the actor, and it is executing the VLLM engine and so on. So this is just a log. You can disable this log, but this is good for a learning purpose. And now if you see, I have all these 4 new columns where I have category, I have the is safe, which is a Boolean. If the model have model felt that this particular frame is safe or not, and also it has the VLM description and the quality. Okay, so it has also added a column called inference error, which is basically, if you read the array data VLLM processor config, you will see that this inference error is something which array adds if the inference fails for some reason. And this happens if you set this parameter should continue on error. Because a lot of times it might happen that the image is not appropriate, or it is not right. It's it might have been corrupted, so your inference might fail. So, but you don't want to stop, you want to continue. So you should you may like to set this parameter as true, which we have done. If you scroll up, you will see that this parameter is turned on. So if you see this, should continue on error, it's marked as true, right? And that's why that column has been added. Okay, so let me just scroll down. So now we have this transformed data, and if you want to see how these 4 columns looks like, I can just enumerate and take the first 3 frames and see how that data looks like. If I now go down, you will see that the data would look like this. This is clip number 0, video I did this, and the category is gaming, the VLM quality is high, is safe, is true, and so on. And there is a description as well. So all of this is coming from VLM. And it is all giving this in a JSON format. So because we have mentioned that in our system prompt. Okay, so that's about this stage of VLM. The next one is very, very straightforward. Is we just have to find out whether the clip is safe or not. And if you remember, we have this added this flag called is safe. All we have to do is we will just check this flag, right? There might be some different technique that you want to add. You can very well do that, but I'm just filtering with that. And then I'm dropping this column because this column is not needed, right? That stage is already done. The inference is already done. I will just drop that. And now if you see the output of this, it would be exactly same, but you will see that there will be less number of rows because it will filter out the rows where is safe is false. And in my testing, when I ran this for the whole data set of Hugging Face, which contains how many videos? Around 43,000 videos. I noticed that roughly around 4 to 5% of the video got discarded. So you can assume that you can save some amount of processing by filtering it out, right? But again, the logic of filtering is completely up to the user and you. But the point I'm trying to make is how you can chain the transformations. Okay, so we are done with this stage 3. And now let's proceed with the next stage, which is the final stage of processing, where we will be generating the embeddings. Okay, so now we are going to generate the embeddings. And how we are generating the embeddings? We are, you remember that we have taken this this 3 frames for clip embeddings. So the way that we are going to do the embedding generation is we will pass this 3 keyframes, and then we will get 3 embeddings. So basically 3 vectors. And then we will take a mean of those 3 vectors. And that is the embedding for that particular frame. Okay, that is what the logic that I have defined. You can define your own logic, whatever works best for you. Okay, and that is what is defined in this stage. So if you come to stage number 4, which is the embedding stage, you see this. The input is the list of frames, and the output is just one embedding. Okay, and if you see this class, we are defining the model here, which model that we want to use, and then we are generating the embeddings. We are generating the embeddings for all these 3 frames, and then we are taking the average. Okay, that's the only thing that we are doing. Okay, and once you have this, you can just import this clip embedder from the stages, the same file. And this file contains 2 functions. One is the init function. If you see this here, one is the init function, and the other one is a call function. So this will create a ray actor, and this is the state of the actor. So this is what array will load only once and keep it in the memory, so that you don't have to, array doesn't have to load this model every time, right? And this call will be used every time it does the inference, right? So that's why this will be converted into or transformed into a ray actor under the hood by ray data. So when you do this, when you call this, and this is the ray data set, right? We call map batches. That means we are saying that pass this data in batches to this class which we have created. So under the hood, this will trigger ray actors. And this is the point that I was trying to make. When you use a higher level API like ray data, ray train, you can simply use the standard way of processing, just like here, without decorating every function with classes, actors, and all that. This takes that heavy lifting, right, from you. But you can very well do this with a ray core as well. But why would you do that when you already have this API, right? So here we are saying that process this data, pass it through this embedding class, use the batch size which I have defined, and use 2 CPUs. So I know that this is a very small model, so I want 2 CPUs to be used for every actor, and I can define how many actors it should be always be up and running, right? So this is where you can define the concurrency. Okay. So that's about the embedding layer. And once you have this, you can check the schema of that. And if you come down, you will see the schema looks like this. If I scroll down, you see this. We got a new column called embedding, which is saved in a torch tensor format. Okay, it's an embedding of size 512 vectors, length vector. Okay, and if you want to see how that vector looks like, and we can actually do a similarity between two vectors just to see how it looks like, you can come down and see that these vectors are like this. Let's say this is clip 0, this is clip 1, this is clip 2. And if you see that these all are coming from the same video, so we expect the similarity score would be high. And you see that this similarity is pretty high. And these are the just first five numbers, because it's a very long list of numbers of 512 numbers. But just to give you an intuition, what is happening under the hood. So that's how you will do the clip embedding process. And as I mentioned, why we have created an actor pool, because we don't want to load the model multiple times, right? So we just want to load it once and do the inference. So that's why we have an actor pool. And finally, you can write the data, the curated data into your sink or into your shared storage. In this case, we are storing it into an S3 bucket. So that's why we are just simply saying the dataset dot write and giving the path, and it will just write it into that location. So this is the location that we are writing. So since we are running it on any scale, so when you create any workspace or any cluster, it will give you a workspace. It will give you a shared storage called MNT cluster storage. So this storage is accessible to all the worker nodes in this cluster, and that is what we are leveraging. But you can consider this path to be any path of your choice. Okay. Now, this is what we have done for the whole pipeline. So since it's a notebook, we are checking every stage and see what is coming in and what is coming out from each stage. But in real world, this can be done in one single go. So if you see here, we will read the data here. This is the first stage, which is in CPU. Then we do the VLM stage. This is GPU. Then again, the third stage is filtering. Again, this is CPU. Then the fourth stage is generating embeddings. We are running it on CPU. And then since the model is very small, that's why we are running it on CPU, but this can be very well you can run it on GPU. And then finally, at this point, till this point, nothing will happen, okay? Because Ray data works in lazy mode, so nothing will happen. The moment you do write.parquet, this is the time the entire DAG will be executed, right? So, and at scale, and every stage will work independently. It will scale independently depending on what you have configured and set, right? And that is what I've just truncated the output, but this is how your entire pipeline would work. And finally, you can see the schema after curation. So after curation, your data would have all these columns. So we started with only MP4 bytes of video, and you end up having having a data which contains video ID, clip index, etc., etc. So if you start with just 20 videos, that means 20 rows, you end up having around 400 rows, where each row will contain all these information about that video. Okay, so that's about the video curation. And this is just a summary what we have done and how we have done. There are some references as well. Before I show you how you can execute it at scale, which is mentioned in this GitHub repository as well. So if you come to this GitHub repository, 1 second. Let me just open that. Yeah, so if you, let me just open this. If you come to this GitHub repository, this is a notebook execution. But if you come down, you will see that I mentioned that if you want to run it on production, you can follow this tutorial. Now, if you click here, you will see that the whole pipeline, how we are running it in one single job. Okay, it's exactly the same, but now what you can do is you can run it through an Anyscale job. For that, you can just log in through your CLI, and you can clone this repository. And within this repository, we have a video curation folder. And then you simply go to that folder and export your Hugging Face token and then submit the job. And the way that you submit is you say Anyscale job submit, and you define the job YAML file and the environmental variables. If you want to run it for the whole dataset, you don't have to give this argument. It will run it on your full dataset. So if you want to see what is there inside job YAML, I just open this this GitHub repository, right? And here you don't have any notebook. This is because this is exactly the same, but when you want to submit it with an Anyscale job. And if you see this, here also we have the same stage.py. And this is my entry point. This is the file which will get triggered when the job is submitted. And the job.yaml, I'm defining what kind of configuration I need for the head node, what kind of configuration I need for the worker node, and all of that. And at the end, I'm saying that the entry point is video curation.py. That's all. So what happens is under the hood, when you run this, if I come to this Anyscale workspace, let me just come to the dashboard. There is something called jobs, right? So we have been working throughout in the workspace. If you come to the job, you will see that there are multiple jobs that I have created and executed. This was one of the job which I submitted. So when you submit this job, when you run this, command, Anyscale job submit with job.yaml, under the hood, Ray will create an cluster on your behalf, and then it will submit this job, and it will just execute. You don't have to worry about creating a cluster and all that. So it will be the configuration that it will use should be defined by you in the job.yaml, and the actual code which it should run should be defined, and it should be mentioned in the job.yaml, which we have seen in the entry point. And the code, it will read from this very directory, and it's the same thing, same code, but it's not in the notebook format. Okay. And now if I want to, if I have to show you this, this is I executed a couple of weeks back. If you see this, it ran for almost 5 hours or 4 hours 56 minutes, and this actually curated the whole data set in the entire 43,000 videos. And if you scroll down, you will see that how the GPU was utilized. You see this? The GPU was almost fully utilized. All the GPUs, I used around 10 to 12 A10 GPUs. And you see that the GPU memory utilization is almost 100%, right? This is what you want. And when you start troubleshooting or playing around with this, you can look into this dashboard and see that how it is working. If you see some of the ohms error, that means that you have to fix something, or your configuration is not correct, or you have not provisioned the right amount of resource, which you can play around. Okay. So with this, I'll take the questions, but before that, I want to share a few of the QR codes. So this is for the GitHub. Okay, I'll just wait for 5 seconds here. I have a couple of QR codes to share. This is the GitHub for this notebook, which we executed. this is the GitHub of the tutorial, like how you can submit the same workload as a job. So this is the tutorial. And then I think the best thing would be just scan this, because this has the slide which contains all the links. So if you have any questions or any queries, you can reach out to me on LinkedIn or an email. My email is suman@anyscale.com. It's my first name followed by @anyscale.com. I'll be happy to answer any of your questions. So I still have, we are almost over time, but if we are fine, I think we can spend some time on answering the questions. Okay, I see a few of the questions, so let me start from the beginning. Okay, all right. So Domago is asking how ray data saturates GPU optimally from 1024 batches. For example, 20% of the core merge the data. Okay, yeah, so that's a good question. So what happens is, the way that array data works is in the form of streams, right? So it will just stream the data, and the way that it works is efficiently uses GPU is it has something called back pressure. So when the data is in this stage, when the GPU is getting utilized, if Ray feels that okay, the data is not I'm not getting enough data to make myself busy, we can always increase the previous stage, and it has a back pressure which will control how the previous stage is scaled, right? So that way, you know that Ray is taking care for optimal workflow, and that is what we see in that dashboard where the GPU utilization is always around 80 to 90%. And the best way to benchmark this is try to use this without Ray and see that you will see a lot of jitters, right? Especially when you use array data with ray train, you will see that when the training is happening without ray data, the PyTorch data loader will wait for the data to be processed. Whereas when you use array data, the data will be streamed in batches, right? And what you will see in the dashboard, if you see the GPU SM utilization, you will see without ray data, there'll be a lot of jitters, because every time that GPU is not utilized, it will be down, right? So it will be waiting for the data. Whereas when you use ray data, you will see that a much smoother a plot, because of back pressure and ray train and ray data integration. The ray train will always prefetch the blocks. So it will just prefetch the blocks from the previous stage, so that the GPU is always busy, right? It should not strive for data. Okay. So let me see what is the next question. What do we do in is safe? Does it mean that the frame is safe or not? Yeah, so we have defined this logic, and we are completely dependent on the VLM output, right? So again, this is more on the application logic. So you can define the logic that you feel is right for you. But in this case, we are just telling the VLM, the model, to tell us that whether this frame is safe or not. So that means it checks. If you go to the definition of this VLM, the model that we used for VLM inference, you will see that it will just check whether this frame is safe or not. So maybe this is a disturbing frame, or it is not accurate, to have it. So it will just say that no, this is not safe, right? So, but again, this is application logic. You can very well use any logic of your choice. Okay, Varun is saying that instead of FFmpeg, what alternative was used? So we used decode. That is what I mentioned earlier. We used decode. So decode is you can check it in GitHub. This is an efficient video loader, right? And this actually under the hood uses FFmpeg, but this is what we used. And one of the reasons that we used is it is easy to convert that into a tensor, and it just reads the file once, and we can use that for the processing, right? And that is what we did in our demo, right? If you remember the first stage here in this stage, when we perform screen detection, quality filtering, and keyframe encoding, all of this happened in one decode open file operation. Okay. What is at the end? What is there is a question? What is the end? What is the end goal after creating the embedding? Yes, that's a very good question. So the question is, what we will do at the end? So at the end, if you see, our data set looks like this, right? At the end, our data set looks something like this, right? And one of the use of this embedding is, you can use it in different ways depending on the downstream process. One of the thing is that you may like to do is you might want to use this embedding to remove duplicate frames. So if the embedding similarity is very similar, you can just reduce the size. So you can compress the amount of data that your VLM would be used for training, right? So this always reduces the computation cost for your training. And also, if you use this whole data set, not for just training, but you can just store this whole data set into a vector store or a vector database, you can very well have an opportunity to build a video Q&A system where you can ask questions and you can get generate a new video. So there are different things that you can do. And one exercise that I would recommend is when you do this, after you get this embedding, store this into a RAG, into a vector store, and query that and ask some questions and see that what video that it is generating and what are the similar frames that it is, not videos, what are the similar frames that it is generating. You will get an idea whether your pipeline did the right thing, what you intended to do. But yeah, embeddings can be used in the downstream process. We just stopped at the data curation side because our objective was just to create this data set from raw video so that I can use this for any downstream process, whether it's creating a search engine or creating training a VLM model or so on and so forth. Okay. All right. So somebody asked, I would like to test this on GPU based on Kubernetes cluster. Yeah. So I can certainly share documentation. Maybe I'll request, I'll share a few documentation to Bill. Maybe Bill can share it to everyone. The question is, how you can do the same thing on Kubernetes. So we do have support for Kubernetes. In fact, most of the customers uses Kubernetes, Ray on Kubernetes. So we can very well do that. So it should be good. So Anyscale creates a new cluster every time you execute. Yes, that's correct. So every time Anyscale, like when you submit a job, if you see here, every time I submit a job, it starts, it creates a cluster, it executes the task. Once that is done, the cluster is terminated. So that's why if I come to this, you see that it is terminated. So it is very much ephemeral, right? So every time you submit a job, it will have a new cluster. That's correct. One question is regarding the Ray actor and driver. If the inference engine is not Python based, how Ray will do that? Yeah. So as of now, it is more on Python. Although we do have support for a few other languages, but predominantly most of the AI workloads are in Python. So that's why our whole engine is more around Python. Yeah. The last question that I have here, which I can see, is other than parallelism during embedding training, where else Ray is used during this process? So in this process, everywhere Ray is used. So the full pipeline, we never executed any of the tasks without Ray. So if you see the first stage itself, or let me just quickly show you the final cell where we executed everything in one go. So if you see this here, we started itself by reading this data using array data object. So it is not like we did something in some different format and then we used array data in only one of the transformation. The whole transformation started with array data. So if you remember this stage, uh, we started by reading it from Hugging Face using array data and kept on doing different transformation using different APIs like flat map. We used map batches and so on. And in this case, we used a VLM. Everything is through one single stream. Okay. All right. So I guess we don't have any further question. So thank you so much again for joining in. Feel free to connect. And if you have any questions, just let me know okay, over an email or on LinkedIn. I'll be happy to answer. And the resources, everything is there in this link. If you scan this link, you should get all the resources which we shared today. But I'll again send all this link to Bill, my colleague, and you will get that in your inbox. So once again, thank you so much for your time. I'll see you in the next webinar. Have a nice day. Bye.
All right. Looks like we have a good group getting started and joining in.
Yeah, we'll give everyone maybe 2 to 3 minutes to kind of roll in, and then we'll kick things off.
Always curious, where are folks calling in from today? One person from San Diego. Nice. Stockholm. I saw Mexico City, Canada, Ireland. Oh, Sri Lanka. Very cool.
Oh, this is great. We've got global participation. That's fantastic.
España, Italy. Nice stuff. Cyprus. I don't know if I've ever been on a session with someone from Cyprus yet. Very cool. Someone said the moon.
Yeah, I mean, there has been a lot of SpaceX discussion recently, so. Cool. Maybe just
Hey
one more
everyone,
minute.
welcome
Yeah.
to
Maybe
OpenAI
just
Build
one more
Hours.
minute,
I'm
and then
Christine.
we'll
I'm
kick
on the
things
startup
off.
marketing team, and I'm here with Steve.
Hi, everybody.
So you might
Zoe's
remember
going
Steve.
to help moderate the chat. And so if there are any questions, I probably won't be looking at it that much, but if there are any questions that pop up, we will do our best to kind of answer them as we go. If
Tools, AI expertise to help you build with our APIs and models. Down below on your screen is our homepage, so you can find all of our past sessions, including Steve's one on Responses API on demand, and this will also be on demand after our live session. So to give you a little snapshot on what we're going to be talking about today. So first, we'll be going through a lot of the new updates on Agents SDK. There's now a Codex style harness that's really improved it, and Steve will walk you through all of these new releases. We also have some new releases in the API that we'll walk through, and then we'll move into a live demo. So this will be the majority of the time that we'll be spending today, and we'll be building an agentic task tracker. And then, as always, we have a lot of time set aside for Q&A. So on the right side of your screen, you'll see a Q&A tab. So feel free to submit your questions. We have our team who is dialing in virtually to answer them during the session, as well as saving some to answer live towards the end. And we'll have a very special guest be joining us virtually to help answer some of these. So with that, I will turn it back over to Steve to walk through some of these slides.
Awesome. Yeah. Thanks, Christine. So great to be back on Build Hour. My name's Steve. I'm an engineer on the API team here at OpenAI. First thing I want to talk about is some of the updates we've made to the Agents SDK in the last couple of months. Kind of the backstory here is that models are getting way better at doing work over long periods of time. A lot of folks have seen the sort of meter chart that shows the ability of models to kind of work on their own for longer and longer periods of time. That's just kind of going continually up and to the right. And there are a lot of great examples of this, even within our own products. So many of you know and love Codex, our agentic coding tool that you can use to kind of build software and do tasks from end to end. You've probably seen it run for maybe minutes or up to an hour. If you've used the goal feature, maybe you've seen it run for much longer than this. Internally, folks have gotten Codex to run for days up to a week on tasks. So these models are really, really able to kind of do things over really long trajectories, which is really cool. We also have this sort of security agent that's built on top of Codex. The models are getting really, really good at finding security vulnerabilities, especially in legacy software. And so we have an agent that's powered by Codex that actually scans repos and our own code and code that we depend on for vulnerabilities that might affect the security of our systems. And then we also have an internal data agent that's kind of powered, again, by Codex, that's connected to our data lakes, able to answer any questions. So I can say something like, how many people are using the Agents SDK? How many requests were there in the Responses API 2 days ago? And where previously I might have spent an hour writing that SQL query, now it's just a simple prompt, and a few minutes later I have an answer, which is really awesome. The reality is, though, that building production-grade agents in your own systems is still pretty hard. it's pretty hard to kind of strike this balance between maximizing performance and having sort of a really flexible, maybe cross-model provider platform. Because more and more the models are kind of being tailored to the individual harnesses, and so it's kind of hard to stay in distribution while also maximizing that flexibility and that customization. There's also a lot of challenges that come with sort of modern computer using agents. So we think of Codex as a coding agent that can do things within a sandbox. Most of the time when you're running Codex, that sandbox is just your local laptop. So those two things are together. We'll talk about how we've switched that up with the Agents SDK. But if you're deploying agents in production, oftentimes you want to be able to run these agents in sort of an isolated environment. And then you have to deal with problems like the container dies, it expires, it goes away. What do you do? Is that thing load bearing? Did you have state on that you then need to rehydrate? This stuff is really, really hard. And then kind of the third thing is like, at the end of the day, you want to be able to have this sort of like really customizable framework you can use to bring your own data in and maybe add your own skills and all of this stuff like this. And so this combination of things is kind of makes deploying agents in production a little bit challenging. The cool thing about the Agents SDK, we've made some updates to it, but sort of the baseline is this open source customizable framework that maybe you've used since we released the Agents SDK last March. It's been around for a while, continues to be open source and super flexible. We've added in this concept of sandbox using agents, and you get to decide where these sandboxes are run. So if you are, maybe a modal user or an EDB user or a Cloudflare user, and you're kind of already using those sandbox products, or maybe you're new to sandboxes and new to sandbox using agents, and but you're already using one of these platforms, we have provided first-class support for using the sandbox products in a bunch of these different platforms like ETB, Modal, Cloudflare, in addition, Vercel, Blacksoul, Daytona, and just things like Docker. And if you just want to use your local laptop for testing, those are kind of all supported first class. And then on top of this is this Codex style harness. So bringing in all of the great stuff that makes Codex, all the great tools that are in distribution with our models, but work great with other models as well. And then some of the cool things like skill use, computer use, memory, and we'll be demoing some of this stuff here in a little bit. So so basically what the Agents SDK is it provides this sort of model native harness that the agent can use in order to kind of do productive work over long periods of time. So if we think about maybe what building an agent might have looked like, a year and a half ago, where you're just kind of using an API directly, an LLM API directly, you would have done something like, you set up a loop, you make a request to an LLM API, you get some stuff back, maybe you get a tool, you execute that tool, you update the context, and then you kind of repeat until the model is no longer calling any tools. You might be layering in stuff in addition to that, like web search, file search, MCP, kind of like spending most of your time building this orchestration layer around this loop, where actually you should be spending most of the time building stuff into your product that makes it much better for your end users. And so Agents SDK is kind of designed to help you do all that stuff and not really think about the orchestration. So the agent loop is built in, again, very Codex-like in its design. Also, web search, file search, MCPs, code interpreter skills, these are things that are all you get out of the box, are really easy to turn on. And then we've kind of added in some of this like sandbox using functionality that I'll talk about pretty shortly. The thing that I'm most excited about that we've kind of done here is we've split the harness from the compute. And what does that mean, basically? So if you can kind of imagine a world where the model is working sort of directly on a computer that it itself is running on. So if you can kind of imagine like Codex running on your laptop is this sort of example where the harness and the compute are tied together. Imagine putting that into production, right? So you have sort of a container where the agent is both running. So like the loop that is calling your LLM API, in addition to working on the same file system, those things are together. This kind of creates a few problems when you run this in production at scale. Your sandboxes become all of a sudden load bearing. And if one dies or goes away, then all of a sudden all that state is gone and you don't have some sort of external place where maybe you can refresh from. In addition, you have to sort of do interesting sort of gymnastics to manage your secrets. You ideally don't want to have any secrets on your sandbox. Otherwise, you might be vulnerable to prompt injection attacks or exfiltration. And so if you kind of split those things up, then you can treat the sandbox as this totally ephemeral thing that you don't really have to worry if it lives or dies. It can expire, go away. And then the harness, which is running maybe in a temporal job or in AWS or kind of wherever your infrastructure is already running, can sort of handle the rehydration and snapshotting and all this stuff. And the Agents SDK is going to make that really easy. And I'll kind of show some examples of this. So Agents SDK kind of like already fully packed with a ton of features that you might have already been using, things like web search, file search, agent memory, text, in addition to some modalities that you've probably been using, text and voice. There are some new things that we're pretty excited about that we've added. So this is kind of first-class support for skills. Networked containers is kind of a new thing sort of in the API and also in the SDK. And then we've also added agent memory. So your tasks can improve over time and get better as they go. So some of the kind of core features here, again, a really Codex-inspired harness, a lot of those same tools, sandbox use, so that your models can work with files in sort of a virtualized environment, do work over long periods of time, write Bash, write Python, write whatever to kind of accomplish tasks. And then, as always, open source, super customizable. So Codex-style harness, what kind of concretely does that mean? The kind of things we've brought from Codex into the Agents SDK are these things like auto compaction, especially this computer use through the shell. So the model is able to write shell commands. The Codex style loop is this sort of async shell interaction loop where it can write a command, maybe wait a little bit. If it doesn't finish, it can go do something else and then kind of come back to those things, and it kind of keeps track of what commands it has running at any given time. And so we kind of brought that into the Agents SDK to allow coding agents to work kind of in any domain, in any infrastructure. And then sandboxes are super crucial because modern work means working over a lot of files. If you think about kind of the work that you and I do every day, maybe you're working in a big code base with a bunch of files, editing files and making your changes. Maybe you're working with a bunch of PDFs. Maybe you are, creating Word documents or PowerPoints. Agents are no different, and they need access to those files and a kind of a place to create those files and store them. And so that's kind of where sandboxes come into the picture. It's an isolated environment where the model has access to some files and can do stuff and produce meaningful output. And kind of again, Agent SDK, open source and customizable. It's been open source since day one. Super, model agnostic. If you want to use other model providers, you're more than welcome to. Anything that kind of uses the responses API format will plug in really well. You can make this multi-tenant super easily. So if you want to have a system that's running the Agents SDK where you're kind of processing many requests from users at once, again, super easy. Made session management really simple. So Agents SDK is going to manage the snapshotting, rehydration of tasks. You can kind of start from where you left off. All that stuff is really simple. Kind of show a demo of that. And then really configurable. You can bring your own tools, bring your own MCPs, and kind of all that stuff. So I want to switch gears a little bit and talk about some other cool things we've shipped in the API in the last couple months. First one is this hosted shell tool in the responses API. So idea here is I want to make just a quick API call. I want to provide some files there that I want the model to do something with. And behind the scenes, we're going to spin up a container, load that up with the files that you've asked us to. The model can write code, do some stuff in that container, and then return the results back to you. So think about this as like a lightweight version of the agent system.
If we have any additional responses for questions that are coming in, then we'll just fire them over within the Discord directly, just so people are aware as well. So do keep them coming in. Just because the stream ends doesn't mean that we're not listening still. But like I said to the other two guys as well, Ash, appreciate the time. Is there anything else you would like to say at the community before we let you go?
No, I mean, just as always, like, really appreciate the opportunity. We know it's been a while since we've been able to speak to you. We're going to do a lot more of that if we can, and you'll see us on various YouTube channels and podcasts and all that stuff. So we are listening. I know sometimes you're question whether we are, but trust me, we're listening, we're in there, and we're going to start talking back as much as we can, whether you like it or not. So yeah, no, I massively appreciate it, and hopefully look forward to doing it again soon.
Love that, Ash. Appreciate the time, mate, and you have a lovely evening, my good friend. See you next time.
See you, Carl.
Love that. Like Ash said, to be fair, a lot of my team just need to organise a few more streams. If you guys are enjoying them as well, let us know. We can also do some potential pre-records, but I think what is good about streams is it's not pre-planned, so then we can go into detail, and then if random questions pop up, we can bring them in. And also it just gives the guys to just be natural, which I think is great for everyone at home. But you can be the one that gives me the feedback on whether that is true or not, because it doesn't matter what I think. It's what you guys think at home. So yeah, but we've got a few more things to talk about. I did see someone asking about clubs. I will be getting onto what's coming in the World's Game update for clubs, but first of all, I want to talk about specifically the brand new tournament mode that is coming in the World Game update. Can't be forgetting about that, but launching next week, June 4th. That's next Thursday, if anyone's wondering. We're going to be bringing the summer's international action to FC26, like the guys have been saying. But we have 53 fully licensed and playable national teams, including 41 that will be in action over the summer. So choosing global powerhouses like Brazil, England, France. It pains me to say that because France are unbelievable, but shout out England. Or emerging international stories like Cabo Verde, Uzbekistan, I'm going to add in Scotland, emerging team there, and more. And you'll be able to experience new true-to-life stadiums, including things like the Gillette Stadium, the BMO Field, and then also Central Moor, which is a new stadium built to capture the atmosphere of top-tier international football. So if you're like me, you love a bit of international football, June 4th is where you need to be jumping on to FC26 and diving into the World's Game update and the World's Game tournament mode. So get involved and bring Scotland to glory like I will be doing, hopefully. I'll probably get bad. But clubs, I had a few questions coming in from the chat asking about new club details, etc. And they are in the pitch notes as well. But I will be talking through them all. So, actually quite a few things coming to archetypes in clubs. So, the level cap is increasing from 90 to 95. Play style slots increasing from 8 to 9 as well. Signature play styles increase from 3 to 4, which I know is a big one for a lot of the club's players. Focused on them play styles. Obviously, there's been a few changes to a few play styles as well. And then fourth, signature play styles can be upgraded to a PS Plus at level 95. So get that grinding in from 90 to 95. I know you will be. And then we've also increased the maximum range of archetype-specific attributes. Now, I'm not going to read them all out. I know it's counter to it. I don't know if that's the right word. Theoretically, you've came to watch the stream, so then you want me to go in a little bit more depth. But as an example, the amount of fourth signature play styles for obviously all the different archetypes, like shot stopper gets deflector, sweep keeper gets far throw, recycler, tiki taka, maestro, incisive. But they're all in the World's Game update pitch notes here. There you have it. So these are the things that are coming to clubs. They should be dropping in a server update very, very soon. So stay tuned for that one. But there you go. The main thing that someone was just asking there is let us know what the level cap is. It's 90 to 95. Let us know, is that high enough for you guys? Is that what you guys were expecting? I know the Discord is very, very active on clubs as well. It's a place for you to also search for clubs and stuff. So you could do that. But if you're watching on a computer, then scan the QR code. But if you're on your phone, that's not going to work because you're watching on your phone. But if you haven't joined already, head over to discord.gg/EA Sports FC. I'm going to put it in the chat a few times from the Real Life of Riley. That's me because I'm watching both on the EA Sports FC account and the Real Life of Riley. So head over to the Discord, fill in all of your details in terms of like connecting it, letting us know if you like clubs, career, Ultimate Team, and you'll be able to see all the channels. If you like everything, then just click everything and then you'll get everything for your roles. My team are running that channel, so we are in there. We may not be replying every single time, but we are looking at the comments, seeing the trends that are going in. We're creating the polls. We're looking to create threads and discussions. There's also a thread for Discord feedback. So if you have any specific feedback for the Discord server itself that you would like us to work on or look into, head over to there and you can add in a comment. There's also a very, very cool section where you can show off your squads, which I know is a massive thing in the Ultimate Team community. So if you have an absolutely cracking squad, if you're going to be firing some Festival of Football players in next week, get that team built up and then put them in. I'm also happy for you to use that, like FootGG, FootWiz, FootBin, and share your teams there as well. It doesn't have to be your team. And people have actually been pretty good in that server channel itself, just kind of giving people feedback and letting them know like who they should buy or what evo they should do to specific players. So yeah, and then the new playstyles lab, and then the Evo changes are going to also spice up the conversations in our Evolutions channel. So very much looking forward to that. But yeah, it doesn't matter what type of game mode that you're playing within FC26, whether it's Ultimate Team, Career Mode, Clubs, Kickoff, you're jumping into the tournament mode as well. We'll make sure that we've got somewhere to talk about that. Everyone is welcome, so get involved. And I look forward to seeing you there. It sounds like I'm signing off, but I'm not, because I'm going to... Sorry, this is the part where I can chill out a little bit, because it's just me. And what I'm going to do is, I'm going to bring up the giveaway tool. And this is what we're going to be giving away. We're going to be giving away, I don't know if you would have seen within the pitch notes, but we actually revealed some of the Festival of Football campaigns that are coming up. And the first one is Path to Glory. Now, that drops next week on the 5th, right? So the 5th of June, the new Path to Glory campaign drops in Ultimate Team. Buzzing. We are going to be giving away some of those items. So we can't show you what they are because they haven't been revealed yet. But what you're going to win is one of the Team 1 of the Path to Glory items. So how it's going to work is I'm going to pull up this giveaway right now. With that, create giveaway. You're going to type a keyword in the chat. You only have to type it once. And the keyword is the world's game. Right? So the giveaway is running now. Got total entry 0 because no one's obviously typed the world's game because I've just announced it. It's at the chat at the bottom there. And let's see if people's entries start coming in. And what is going to happen is, you're obviously not going to get the item straight away because it's not out yet. So what will happen is, after the items have released, you will receive... we're going to contact you via Twitch first of all. Right, I'll start again. The winner is announced. Congratulations. We will message you via the official EA Sports FC Twitch account. What will then happen is you will receive an email once you've given us that detail. So we're not going to ask for any like passwords or any personal information. So if any other channels are writing, messaging you, they're not real. It's only the official EA Sports FC Twitch account. It's got a little purple tick as well. I will be sending them straight after the stream finishes. Yeah, just type the world's game. Type it like this. There you go. And what we're going to be doing is we're going to be... sorry. You'll get a message. You'll then get an email. Fill in the email. What the email will do is you'll be able to choose the player that you want from the team. You choose that team and then the item will then be granted. Now, because we're doing this a little bit in advance, you're obviously not going to get the player straight away. So the emails will likely go out on the week commencing, if I get it correctly, the 8th of June. So the week commencing the 8th of June. So I do still check the DMs, so I'll keep an eye out next week regarding if a few people are like, oh, I've still not received my message. You won't have received an email until the following week. And then what I'll try and do as well is also DM everyone that's messaged before that week. Just be like, hey, just to let you know that the emails have been sent out. Because obviously I know it's been a little bit long. So yeah, type the world's game. Hopefully it's not case sensitive. Let me double check. We've had like 400 submissions, I believe. So it's pretty good. I'm going to roll the first winner now. Grown Up Gamer is the first winner. I forgot to say how many we're actually going to do, but we're going to do 10 overall. So 10 Path to Glories being given away. Shout out to our producer. You don't have to put the names on the screen if you don't want to, but I have put them at the bottom of our document that we're working off. So Grown Up Gamer says, wow, congratulations, buddy. You are the first winner of the Path to Glory item. So shout out to you. I'm going to draw the next entrant. Darky _ DTLL _ you have won yourself a Path to Glory item. Let us know in the chat. I was going to say let us know who you think you're going to choose, but the item hasn't been the items haven't been revealed, so I can't ask that. The next winner is Stepion with a 0. So congratulations. Oop, I forgot to copy the S. Stepion 0, congratulations. Remember, type the world's game. The best way to do it is just type the world's game. No caps or anything like that. The world's game like this. Shout out to you. I'm going to let a few more people enter the chat. All the T's and C's will be sent through as well. But I appreciate everyone who's entering. And we're going to roll a few more now. Suddy. Congratulations. Oh, I keep copy and pasting the wrong names. Well, not the wrong names, just not the full name. PvE Invader. Wonder if you're a big fan of career mode. Right, I'm going to have a drink as well, chat, because it's quite warm today. Shout out to all the streamers, all the content creators. Used to work very closely with a lot of you. Anyone who's in England or Great Britain who's streaming, creating content, or anyone who's working in that, well, actually working in an office, you've probably got aircon. And a lot of creators have aircon too. But basically, anyone who's sat in a room with a computer and is boiling, shout out to you, respect to you, because it is very warm. That's my only British weather mention that FC Direct will get on this stream. But yeah, there we go. Wow from Suddy, there you go. PV Invader, congratulations, bud. Drawing the next one here, X Kumar 22. Oh no. I've drawn your name, but I can't copy and paste. There we go. 1, 2, 3, 4, 5, 6. 6 winners. 7th winner coming in as well. Cry 3, 4, 5, 6. Oh, Chris, maybe? Is that Chris? Is it? Who knows? Cry 3, 4, 5, 6. Congratulations. Suddy said, how do I claim? I'm going to message you on Twitch via the EA Sports FC account. PvE Invaders asked, have I won? Yes, you have. I'm going to message you via the EA Sports FC Twitch account. Don't you worry. The message will be coming through. Chris just said yes with a thumbs up. Or Cry. I assume he's saying yes, as in that is his name. It's Chris. Happy I got that one. Bell OJ10. Congratulations, you're our next winner. 1, 2, 3, 4, 5, 6, 7, 8. We've got 8. We've got 2 more. 2 more people to roll. It's been a great stream, guys. Nearly an hour in. I'm also going to be looking to find our next person to host. I am by myself at the moment, but we are going to be bringing in a few new members of the team to help me out. But shout out to Kieran, who was unfortunately or fortunately because he can't help with the giveaway today at the E-Champions League final, which was on the Twitch channel yesterday, and I hope you all enjoyed that. So there you go. There you go. Right. Before we end as well, after I've rolled these few things, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, before I reveal the last item, I can't be forgetting about EA Sports FC Mobile, the world's game. Now, they also, I say they also, like, it's not, I'm not part of that team as well. We released a deep dive of pitch notes regarding the FC Mobile World's Game Tournament update, and I'm going to share it into the Twitch chat right now as well for you all at home, because I do know a lot of you, like myself, play both, play FC Mobile and FC 26. So head over to that if you haven't already had a look to see what is to come in EA Sports FC Mobile. But I can give you a quick rundown. In National Glory, new fully immersive tournament mode. Choose over 50 national teams. Create your own journey and fully customizable experience. There's going to be cinematic videos, updated goal celebrations, new stadiums. There's going to be total customization. You choose your national team, you choose your difficulty, you set the schedule, set up your team the way you want to in FC Mobile. So head over to that link that I've just sent over there, and it's going to give you all of the details that are coming for EA Sports FC Mobile, the world's game. Shout out to them. Shout out to the team working hard on that, as well as the FC 26. We're all a massive family here. Right. 1, 2, 3, 4, 5, 6, 7, 8, 9. One more winner. Fingers crossed for you at home. I don't know if I announced the most recent winner, but it was Zop Underground. Zop Underground, congratulations. The final winner is, what a name. What a name to win. Roy Rogers 92. Congratulations, Roy Rogers 92. You have won yourself a Path to Glory item. Congratulations to all the winners and commiserations to everyone who entered. But make sure to tune into our future FC Direct streams. And make sure to stick around, actually, because we're going to find someone quickly to host as well. Let's have a look at who we're going to push you towards. Right, I'm going to keep it easy for myself. I'm going to choose someone who's near the top and a good friend. And hopefully you're going to be seeing him involved in future things as well. So what we're going to do is we're going to start the raid. Hold on a second, chat. We will be doing this right here. Producer Matt, can you confirm? Do we have music playing in the background? Okay, cool. I wanted to say, hope you're all enjoying the music behind me while I do these very admin-y things. But I wanted to confirm there actually was music playing. So there is, very faintly, but hope you're enjoying it anyway. While I get the person that we're going to raid going. Right here we go. I found the button, I think. Right, I'm going to send you over to, unless I got a message from anyone saying who to send it to. We're going to give the foot accountant our raid. So thank you very much everyone for tuning into the stream. Like I said, make sure to follow over on discord.gg/EA Sports FC. Let us know your feedback, comments, anything you want. Let us know. Hope you've all enjoyed all of the devs that have been on the stream today as well. It's been really, really fun chatting with them all. Shout out Michael, Judy, and Ash taking up their time to come and talk to you guys, being super transparent with everything as well. And yeah, I hope you all have a lovely evening, day, morning, wherever you are in the world. And I'm looking forward to playing the world's game with you all especially next.
As done here. So let's see. I think the last thing I want to show here is sort of the ability to mount external buckets to your manifests in a way that allows you to kind of bring in external data. So what are the reasons you might want to do this? Let's say you have either a ton of files. Let's say you have like hundreds of PDFs that you need the model to be able to work through. And it's kind of annoying to just have to copy all of those to a sandbox every time you want to spin it up and have it do some work. Or let's say you have data with a strong freshness constraint. So the data is changing all the time and you want the agents to be able to work over data that is like super live. In either one of these cases, mounting data from a centralized source of truth instead of copying it in, where it might already be out of date by the time the agent starts working, is pretty critical. And we've built that natively into the Agents SDK. So if I go to if I go here, what I'm going to do is kind of comment this in, and we've built this R2 attachment store. And so this is kind of doing a couple of things. This is taking our uploaded files, and then instead of just putting them on my laptop and then copying them to the container, we're actually now uploading them straight to R2. So that's going to be our source of truth just for our application layer. And then back in the manifest, we're saying if we are using this R2 attachment store, then we're actually going to use a different manifest here. And we have a similar layout. So we have task and then these 4 folders, but instead of the input being an empty directory that we then copy files into, we're instead saying, I want to use this S3 mount type. And we're technically using an R2 bucket, but we're using the S3 mount. The reason is because R2 and S3 are API compatible, so we have one object for them both. But as we look through the parameters here, we can see we're using this R2 bucket name, we're passing the access key and secret key, and then we're using this modal cloud bucket strategy. A lot of these sandbox providers, modal included, have native ways to mount external volumes to their sandboxes. And so we're using the sort of built-in one for modal. But if you're using a Docker container or sort of any generic container, we provide a couple out of the box. You can either use rclone or Fuse, and these both work equally well, and it will depend a little bit on your systems, which one will work better for you. But they're both provided out of the box, so pretty easy to just plug this stuff in. And so now I will go and create another issue here. We'll say edit these assets again, please. And we'll grab our files, drop these in, hit create. And we should see, so this has been, I didn't assign this, but we'll sign in a sec. What I want to show here though is now we have, if we go back to our bucket, we now have tasks and we have a reference to our task here that has all the files in it. So now if I go back and then assign it to our program editor and say get started, hit send, it's going to be able to, we'll watch this thing spin up, and then it will be able to read and write to this volume, just like it would if it were on the file system local to the container. So you can kind of bring in these places of context of file storage from kind of anywhere across the internet, and the model will be able to access it as if it were on the local file system. It's completely opaque to the model that it's actually operating over the network. So there are some trade-offs here. You might incur some additional latency as the model is kind of like LSing maybe a large bucket that takes a long time to list all the files through. But there's sort of this really nice trade-off that you get where you get to maintain your freshness constraint or have it work over a ton of files without having to sort of like copy all of them all onto the container where you might be sort of like limited in space. So cool, we can wait a sec for it to see the spin up, but that kind of brings us to the end of the demo here. We kind of covered a bunch of cool things. We showed how we can build agents that both inspect files, spin up sandboxes in kind of any environment that you choose, maybe one that you're already using, agents that can edit code and kind of like work on these long horizon tasks for maybe minutes or hours or longer over whatever period of time that you want and whatever context you want. So yeah, with that, I think we'll do some questions.
Yeah.
Cool.
Okay, next slide. I'm really excited to welcome Nish on stage with us. So Nish is product for agents. Nish, do you want to give a quick intro?
Hey guys, yes, so product manager on agents, really excited about the stuff we're doing with Agents SDK. Been answering some of the questions in the channel, really great questions, and yeah, excited to get into it.
Awesome. Okay, next slide here. Perfect. So the first question, when are harness-based agents best versus building with just Responses API?
Cool. Yeah. So I think that the Responses API is great for a huge variety of tasks. I think the places where it really shines and it's an agentic model by default or agentic API by default. And we kind of talked about that in the Responses API build hour from October. It really shines, I think, if maybe you're using a language where you can't find a really good sort of agentic framework that you like. So maybe you're building in Elixir, maybe you're building in Haskell or something a little bit more, say, esoteric. You can always just build on the API. You can kind of recreate a lot of these concepts yourself. It might be a little bit more work. Sort of like harnesses are becoming sort of like really key to how the models operate. So in particular, the Codex harness with OpenAI models is sort of like becoming more and more coupled as time moves on. And so, in the future, it's very, very possible that you will be able to get the best performance from the harnesses that the models were trained with. And so that's where kind of the harnesses are really going to shine. And also, if you are using an environment where you can kind of drop these things in, it just is making, if you're building agents, it's going to make a lot of this stuff super easy. However, if you're doing, kind of one-shot tasks, like maybe a translation use case where you just need to just one-shot translate a document, or, taking unstructured data and structuring it into JSON or some other format, Responses API just out of the box is going to be really good at that stuff. And you can use all the hosted tools to kind of have these like really light agentic loops that are pretty easy to orchestrate in just one API call. Cool.
Okay, next question. Does the Agents SDK feature any built-in out-of-the-box persistent state management to handle this pause and resume behavior natively?
Yeah, totally. So I showcased a little bit that snapshot mechanism. That's totally out of the box. That works if you just start using it. The only thing you have to define is kind of where you want to store the snapshots, whether it's in R2, as I mentioned, or just kind of local to disk, which is the default. And so this is kind of that, really out of the box thing where it will take one sandbox's file system and then zip it up and then put it somewhere else so that another sandbox can resume from the point where it left off. But also the run state is sort of managed. So if you can think about two pieces of state here, it's kind of like the file system, and then all of the messages in that conversation so far that the agent will need to continue from. Agents SDK manages handling kind of like both of those pieces in one shot. And so you can take that thing that has both a pointer to where the snapshot's stored and then also the full rollout. And then you can store it in your database. It's just a JSON object and then load it back up later. And then you can kind of resume losslessly, maybe if you have sort of a multi-node system or something like this that just has the database to share state.
Nish, anything to add there? Or we can move on to the next question.
Yeah, no, I think that covers it. Like essentially, we store the rollout and we also snapshot the file system, which is a little bit unique compared to other SDKs. So you should be able to resume very like long-running, day-long agents pretty easily.
Cool. Yeah. Okay, next question. How would you compare the code executing harness in the Agents SDK via the sandbox agent versus the actual Codex harness? Yeah. Any capability?
Nish, you want to take this one? Or?
Yeah. So there are some sort of small differences between the sort of like actual Codex binary and the Agents SDK. Agents SDK does come with a lot of those core capabilities. Some of those are like the bash tool, the way Codex edits files, skills, memories. There are some things in the Codex binary that we are still going to like build into Agents SDK eventually. The Codex binary is like this sort of like multi-threaded thing that you can run multiple different subagents. In Agents SDK, we have this concept of handoffs. So you can do something like very similar in Agents SDK. You should be able to do like a lot of the things that you can do in the Codex binary in Agents SDK. But yeah, ultimately, like Agents SDK is like very much in distribution to the Codex harness today.
Awesome. Thanks, Nish. Next question. Can agents persist and restore long-running workflows automatically?
Yeah, definitely. This is kind of what I showed in the demo. It's kind of like very easy with very little. We didn't look at a lot of my orchestration code, but there's not really that much to it. Just kind of kicks off the SDK, stores the rollout, that JSON file in a file just on the laptop, and then is able to kind of resume pretty easily. So yeah, I think most of the sort of engineering that you'll do is figuring out what tools to bring in, what skills should I add to the agent, and the sort of orchestration of starting and stopping and resuming tasks is sort of just out of the box.
Okay, can the sandbox get auto-destroyed after the task is completed, or is it a better pattern to keep the sandbox running?
Yeah, this is a great question. So I actually only demoed one mode of the Agents SDK, but there's two ways that you can use sandboxes. You can do the sort of what we call SDK-owned sandbox, where when you spin the task up, if you just provide it the recipe for creating the sandbox, so you provide it one of the clients, like a Docker client or an ETB client, it will handle spinning up that sandbox for you. And then when the turn is done, it will spin that sandbox down. But you can also eagerly load a sandbox. So you can kind of create a sandbox out of band and then pass the reference of the sandbox to the agent. And then that's what we call like user-owned sandbox. And so you would handle managing the lifetime of that thing. The SDK won't automatically spin it down at the end of the turn. So you can kind of keep it warm and then use it across like multiple turns instead of spinning it up and spinning it down. But the out-of-the-box behavior is that we'll handle spinning it up and down so that you don't end up in a situation where you built your demo and then all of a sudden you have 100 sandboxes running in the cloud that you're paying for, and it's kind of providing a bad outcome. So there's a bunch of different ways that you can use this. But yeah, by default, the Agents SDK will handle the lifetime.
Okay, how should I populate and persist my file system?
Yeah, happy to take this one. So essentially, we have this concept called the manifest in Agents SDK. The thing that I really like about the manifest concept is you can kind of choose how you want to populate and persist the file system into the sandbox. So you can essentially copy over all of your files from cloud storage into the sandbox, or you can mount all of those files onto the sandbox. And there's sort of like different benefits of either. If you copy over everything, like during the runtime, the model will be able to read the files a lot more quickly, but startup will be slower because you are copying like sort of this big blob into the sandbox. And there's sort of the second world where you can optionally mount something on the sandbox, and startup will be like very, very fast, but like over the runtime, it has to like read these files over the network. But the nice thing about Agents SDK is we kind of like let you do multiple different ways to kind of like mount or copy over things in the sandbox and then persist that after the sandbox spins down.
Awesome. Thanks, Nish. Okay, last question here. Can a supervisor agent monitor and coordinate hundreds of specialized agents simultaneously?
I think the answer is yes. It would take a little bit of work to kind of spin this up, and we have some cool stuff around sort of like multi-agent frameworks that's kind of coming in the near like weeks and months. So it will get a lot easier to do this in the future, but there's nothing kind of stopping you from doing this now. You can kind of go crazy with agents and spin up a ton, and then have one that can kind of check on the status between them. I think like ways we've seen good coordination patterns is either through messages. You can give the parent agent a tool that allows it to understand what sub-agents are running and then check in on them. So kind of like check in on progress, or you can sort of like have them all communicate via the same file system or like a database or something like this. There's kind of a variety of communication mechanisms you can use to coordinate them. But yeah, nothing's stopping you from doing this. And I think that this sort of massively parallel work will become sort of the default in the near future.
Love that. Okay, so let's wrap up with some resources. So on the screen here are everything you need to know to kind of get started with Agents SDK. We had a ton of questions also in the chat about your demo and where they can find this. So on the very bottom is our build hour repo. We have all the code from the last build hours, and we'll be posting that very shortly, right after we're off camera. Then for any upcoming build hours, feel free to check back on our homepage. So if you hit the next slide, we show you just the link again. And after this session, we'll email out a survey. Let us know what topics you want to hear about next. And we'll also include the link for this recording so you can catch up. If you missed the beginning, you can get up to speed there. And
on instead of off in your settings. This means that when you press your R2 for 100%, you will just sprint as you would do normally. Do you press your R2, let's say, between 40 and 70%, your player will have a controlled dribbling. And obviously, the cards in the game always play a big part in the meta. For 500k coins, you can buy yourself this squad right now. So you don't need 20 million coins anymore. A team that costs 500k coins is almost at the same level. Do you guys think this is good? That almost everyone